say, because the child has no knowledge about this. So the child's parent, they will give some brief about that how the structure is indicating this thing. So according to the environment and according to the knowledge, the child will learn something new. So and after few years, the child can identify that this thing is one type of laptop. Now, after that, if I ask the child, the same thing, the structure is also same, but the thing is not laptop. After after that also, the child will say that this structure is belongs to the laptop class, but the child is wrong, right? Because the child has trained with this data only, that if this data belongs to, if this structure, if this cell belongs to, if this pattern belongs to this class, so that means the all the structure which are the same type, all the structures are belong to the same class. So so but after few years, again the child will learn that no, this is not laptop, the structure is same. After that, you will know that the child, he or she will know that this structure is not identify the laptop every time. So we have to learn through the experience. The child has to face through various types of experience so that the child can learn what is the actual thing. So according so the intelligence may be the capacity to acquire and apply the knowledge. So based on that rule, we can define the artificial intelligence learning into three. So all of you know that that is supervised, one is supervised, another is unsupervised, another is semi-supervised. But another is there, that is reinforcement learning. Sorry, my handwriting is a little bit bad. Another is reinforcement learning. So what is the supervised? Can anyone explain what is supervised? And, and what is unsupervised? Can you explain? Does not have a target value. We do not know what we are wanted to predict. Yes. So this so when the child was born, at that time when I was asking the child that can you tell me which type of structure is this, so which type of class is this, so at that time that learning to that child was unsupervised, because that child didn't have any data or any information about this laptop, about this structure. So when the child's parents or another person or another any person, when they gave the information about the structure of this laptop, then again when I will ask the child again, so can you tell me which class is this, that time it will be coming under supervised, but still it is not fully supervised. This is semi supervised. Why this is semi supervised? Because if I give the same type of structure, but if that thing is not belonging to the laptop class, then that is again coming under unsupervised. So the model of the child or the brain of the child has already trained with some data. So that training purpose, that training procedure is coming under supervised. But after few years, again when I will ask with, suppose again I will ask, so the child has trained with this structure. If I ask the child with this structure, so at that time, the child cannot say what is this. So again, it is coming under unsupervised. So now child can say this is a marker pen, but the same structure pencil may be there. So that is coming under semi-supervised. So the brain has trained but not fully trained. It is partially trained. So that is coming under semi-supervised. Now coming under reinforcement learning. So what is this reinforcement learning? The purpose of the reinforcement learning is to gain knowledge through the experience without getting knowledge from another person or any set of data. So suppose that child is using this marker pen. So through the experience, when the child was using this marker pen, through that experience, the child was get to know that this is the marker pen without getting any knowledge from another person. So that is coming under reinforcement learning. That is coming under reinforcement learning. So first is the supervised learning. So reinforcement learning is the most critical task because it actually clones our brain. The purpose of the AI is to clone our brain, right? So the reinforcement learning is one type of our brain. So it is actually very much difficult to implement the reinforcement learning. So nowadays maximum people use supervised. Few organization has gone to unsupervised. Some big organizations and universities, they have gone to unsupervised. So still people have stuck in these three: supervised, unsupervised, semi-supervised. But reinforcement they are trying to integrate, but it is actually one type of AI HUD problem. How many people heard about AI HUD or AI complete problem? Anybody see? Okay. Like in algorithm, we had a problem that p-type problem, np-type problem, right? Another was there, right? np-hard problem. What is this? What is this np-hard problem? Np-hard problem is coming under soft computing. So anybody knows soft computing? What is soft computing? What is hard computing? What is soft computing?
It's about neural networks. Neural networks is how to train the data, how to do the calculation functions, and the integration of neuropathy, integration of physiological.
So computing has two types. One is hard computing. One is hard computing, which works on which set. Which set means what set we know, like either 0 or 1. Either person is inside the room or outside the room. But another is there that is called soft computing. Is the name is the soft, but the soft computing is the most critical task in computation. So, what is the task of the soft computing? The task of the soft computing is to find the optimized value. Like all of you had a traveling salesman problem, right? It is one type of soft computing problem. The problem statement of traveling salesman is you the one salesman is there of a company. The salesman has to cover as much as city with minimum cost and minimum time, and the salesman has to sell, and actually the company has to gain more profit. So that is coming under soft computing because it is actually very much difficult to implement that program. So inside that soft computing, this AI is coming. So under that AI, so in algorithm we know that ENP NP-hard. So NP-hard is one of the most critical computing tasks. That is, we cannot solve. We cannot solve in polynomial time. We can solve in order of n square. So many problems we can solve in order of n square, order of log n. So this we can solve within polynomial time. But when it will come order of n to the power n, order of n to the power m, can you tell when it will be finished? We can't say, right? Because we don't know the value of n, we don't know the value of m. But in this case, we knew that this is the value of this is 2. So it will be finished within order of n square. I don't care that is n square plus 4n plus 1. I don't care that because n square is the quadratic. So I will take the maximum power value. In this case, so this is actually NP problem. The problem of NP is non-polynomial time algorithm. So like that, AI also has two types of problem. One is normal AI or weak AI like this. Another is strong AI. Strong AI is like AI had problem, NP had problem. Like we cannot solve those problems very easily. Like one of those AI had problem is uh, sentiment analysis. We can say that sentiment analysis is the basic text classification. But if you go more inside of that sentiment analysis, something will be coming. Initially, it was coming positive, negative, right? After that, suppose now you are not stopping in positive, negative, you want to go more deeper. It will be coming neutral. After that, if you want to do more deeper, you have to know if the person is positive, how much the person is positive. If the person is negative, how much the person is negative. If the person is neutral, how much the how much percent the person is neutral. So if you go more deeper, then you will get to know if the person is positive, because 100% positive is not possible. When I'm saying the movie is good, that means I'm positive to the movie, but I'm not 100% positive. So something neutral, something will be there. Suppose 95% positive, but 5% will not be positive. Suppose 99% positive, but 1% will not be positive. So what is this 1%? What is this 5%? Where are they going? It may go to negative. So when the 5% is going to the negative, so these positive, negative, neutral are the outer structure of emotion. Now the emotion will be coming. When you will go to more deeper of the sentiment analysis, then it will come emotion. What is the emotion then? So if you are positive, so what may come under positive? Happy, satisfaction. If you are happy, how much percentage you are happy? Are you really happy? If you are 95%, I'm saying that you are 95% positive. 95% positive means it may be you are 90% happy, 5% you are satisfied. Just normal satisfied, just normal happy, not fully happy, right? Like this also. Suppose you are 5% is negative. So in this negative class, it will be coming angerness, angry. How much you are angry about that movie, and why you are angry. Those are coming under actually. So this sentiment analysis is coming under one type of AI hard problem. So in NLP, we share that term NLU, natural language understanding. Okay, so in NLP, what is coming under NLP? Like partial speech tagging, entity recognition, these are coming under NLP. So when we will go to solve that NLU, that time we have to apply NLP. After that, we have to apply that type of algorithms which will solve the NLU problem. So today our workshop is one conversational agent. Conversational agent is also one type of NLU problem. Why? Because suppose when I'm asking someone, how are you? So I don't know which type of answer the person will give. Okay, so as a human, I cannot identify, or I don't know that which type of answer the person will give. I am bad, I am good, I know whatever. So how will we expect that correct answer from the system? Okay, so this is AI is a conversational agent is also one type of NLP program. So that is coming under the strong AI. Another is weak AI. Weak AI is normal, just something, some libraries, packages, and that is not that much problem like regression problem. If I want to predict the house price, suppose I know the data set in this areas, the houses height is this, 2 BHK, 3 BHK, so the prices are this, so I have to predict the house price. Those type of problem are coming under weak AI. So this AI had problem, NLU problem, or energy also. Another is there, energy. What is called natural language generation. So these are the main components of proper NLP. Okay. So that all those problems are coming under strong AI. In strong AI, so actually the main purpose of AI is to clone the human brain. So what is our human brain? Human brain is the one of the most critical place where no scientist can enter, because no scientist has single bit of idea how a single neuron works. But in our human brain, there are more than 10 billion neurons are there. So, but no scientist has any idea how single neuron works. But they are going to clone our human brain. So, strong AI is actually full of cognitive. So, anybody knows what is cognitive? Cognitive architecture, cognitive science. No, cognitive is fully emotion. Cognitive is fully emotion. Like not only emotion. If you see, suppose 10 years back you heard one news. After that you didn't listen anything about that. So after 10 years, is it possible to remember that? It is possible to remember that, but not properly, right? Because when after getting one news, or suppose today I have this marker pen, so I know that I have this marker pen, but from tomorrow if I not use this marker pen after 10 years, so how brain, then what it will do actually? Brain every day it will, now I have the marker pen, so brain has assigned one priority value to this marker pen. That I have the marker pen, brain has assigned one priority value. Suppose it may be 95, it may be 98, I don't know, whatever. Okay, so from tomorrow, if I will not use this marker pen, every day our brain will decrease that priority value. It will not be zero. I'm not saying that if after decreasing, after 10 years it will be reached to zero. I'm not saying that, but it may be tends to zero. Okay, so after 10 years, it will be very much difficult for me to remember that at this time, at this place, I had this marker pen. It will be very much difficult. If I come the same place, that time I may remember, because that time again the brain will assign the new priority value so that I can match with the previous priority value, previous experiences. Then I can identify that, I can remember that I had this marker pen at the same time. That is cognitive mind. So that is coming under strong aim. That also scientists are trying to clone, but it is a little bit difficult. Okay, so when actually in 1950, actually, AI started many years ago. First, Aristotle gave the definition about pattern recognition. All of you heard about pattern recognition. So, pattern recognition is also one type of AI problem. What is pattern recognition? Actually, what happens when we classify any object, when we classify anything? First, we extract the patterns of that object. So that is coming under pattern recognition. Still, we use pattern recognition, but we don't know when we are using the pattern recognition, but we are using the pattern recognition. So first, Aristotle gave the definition about pattern recognition. But since that time, there was not that much computational power or anything, so no one could use that. Again, it came in 1950 with through a chess game. So after that also, then how to know that this system is intellectual? This system is working as per human brain. So that time, Alan Turing gave a test. Turing, that's called Turing test. Turing test is like this. Like in a room, there is a laptop. From another room, one person is trying to chat with that machine. From through another machine, one person is trying to chat with that machine. So without getting help from any person, that if that machine will reply, so that means it is the intellectual machine. It is going to be a AI machine. That is okay. Now the components of AI. So you have seen that in so many places there. writing that AI slash email, AI slash email DL. Is it correct? It is not correct, I think, because so many components are there in AI. Because email is the small part of the AI. NLP is another part of AI. So the diagram is there. So AI is, since AI is a vast problem, so AI is one type of human, but we don't know that we have five sensors, right, in our human body. We have five sensors. So in AI also, we are trying to integrate those five sensors systematically, but it is not possible to integrate naturally. So we are trying to integrate through program. So those are coming under NLP. And NLP is like natural language processing. So what is natural language? Now I am speaking. That is the natural language. Now I have written here. That is the natural language. So if anyone is writing, typing, so that is the natural language. So what is the natural language? This is the AI. This is the AI. ML is one part. Inside ML, there are DL. NLP is one quite overlapping here, I'm telling you. And computer vision is also there, image recognition is also there. So they are also overlapping. Overlapping in the sense, NLP is the separate problem. We use ML algorithm, we use DL algorithm to solve those problems. But NLP is the separate problem. NLP has its separate topic. So what is this NLP actually? Natural language processing. When I am saying the natural language processing, when you are saying this sentence, natural language processing. Okay, first let me explain this. Then I will come to natural language processing. Okay, first natural language processing. Okay, then knowledge representation. What is knowledge representation? This is one type of knowledge graph. How many people knows about knowledge graph? That is one type of taxonomy, one type of knowledge graph. So knowledge graph is like, suppose I have written one sentence. Suppose I have written one sentence. Anything. Suppose X is in London. So this person is in London. If I want to represent in knowledge graph, I have to represent in knowledge graph. Actually, knowledge representation, knowledge graph, they are useful to increase the search process. When I'm saying that X is in London, so after giving this quotation to you, if I ask you that where is the X now, then your brain will search in sentence. I saw that X is in London. That means the current place of X is in London. So how the brain is working? Actually, when I am seeing the sentence, brain is automatically creating one graph to of that sentence. How it is coming? So X is X is a person name. Is in London. So this is the relation. I will come to the relation in NLP, how to extract the relationship between two words. And this is the London. This. So when I'm asking where is the London now, sorry, where is X is now, where is the current location of X? So at that time, system will check in. So another nodes are also there. So this is one type of, suppose one type of full set of graphs. So system will search where this person is, where the person nodes is available. Okay, so all the neighbors, all the children of this, which information you will give of against this person, everything will be connected with this. So suppose is a person. Is a person. So the system will search where the X is available. If X is available here, then it will search which nodes are representing the location. Which nodes are representing the location. So at the time of relation extraction, you have to know that is in means it is identifying the location. So it is identifying the location. So that time only the system will give you the answer that X is in London. That means now the current location of X is London, because from this age the system will get to know that is in means it is identifying the location. So when the age label is the location, at that time it will follow the edge. It will follow the edge until another node will be coming. So when this node is coming London, so at that time it will stop here. After that, again it will start to search any edge is connected with London or not. Because I can say that X is in London and he was in USA. So again another portion will be there. So after it, then the user will search, the system will search any edge is connected with London or not. If any edge is connected with London, again it will check that that is connected with location or that is connected with what. So based on that, again it will go through that. I think you have seen Google Knowledge Graph. Anybody has seen Google Knowledge Graph? When I search in Google anything, then one right side panel result comes, that is from Google Knowledge Graph. Okay, so that is knowledge representation, how to represent the knowledge. Then it is coming automatic reasoning to answer questions and draw conclusions using stored information. Automatic reasoning, this is coming under question answering system. Question answering system is another NLU program. Question answering. Question answering and conversational agent are different. That is not same. Conversational agent is when I'm talking to you, when I'm asking something to the app or to the any person, that time the bot will reply me or the person will reply me, that is coming under conversational agent. Another is question answering. Question answering thing, like you have seen in exams that examiner has given you one paragraph. Based on that paragraph, some questions were there, right? So that is called question answering. That is, yeah. So that is under coming under question answering system. That is coming under, actually that is another NLU problem, another airhead problem. So another is ML, machine learning. Machine learning, all of you know that what machine learning does. Actually, first it extract the patterns of the object or of the sentence, whatever of the speech, anything. First, it will extract the patterns. Based on the pattern, then and the model has already trained. If you use supervised learning, so the model has already trained with supervised data set. So based on the data set and based on the pattern, the MLU will classify. Okay. And then it is coming under computer vision. It is image recognition. So you have to identify this is marker or X-ray. If I give you one X-ray plate, you have to identify that bone is that portion has broken or not, like that. And that is robotics. So these are the components of AI. Now the goal of AI. The goal of AI is, we know that AI wants, the scientist wants to use AI to clone the human brain. So how it will help us in engineering and scientific, in any field, not only engineering, scientific, in study, in education, every field, how it will help. So in the engineering field, it will first, it will suppose if you want to create any conversational agent or question answering system. So in that case, so that suppose you have a company and you don't want to you don't want to hire any person to give support, so that you can create one conversational agent. So in that, through that agent, you can support the people, you can support your customers. So in that case, AI is helping you. And in scientific, suppose in scientific, actually in scientific, in image recognition, it is also doing very good nowadays. So a few days ago, one study there, one some researchers has published that their image recognition model is better than radiologist to identify this MRI scan and this. So in this case also, AI is working good, and our goal is to the goal of AI is to automate everything to like a human brain, everything to automate like a human brain. Now I'm coming to natural language processing. Okay. So before going to this is the levels of NLP. So what is NLP? NLP is not only the text. NLP is comprised with speech and text. Whatever is coming under natural language, it may be language, it may be text, it may be speech, or it may be another thing. So what is language actually? We have so many medium to express our feelings, to express our thought. We have so many medium, so we can express through any video, we can express through any image, anything. So what is the language? Why we use the language? Why the language is required? Because language is the more easy to understand. Because if I will show you one image that just identify what I am trying to say, what I am thinking, so it will be more difficult to identify from the image, right? So if I speak with you, if I give you one some words, or if I send you a text message, then that will be more easy to understand what I'm trying to say. Okay, so NLP is like natural language processing. So language, we know that this is a what is language? So language is set of words, set of feelings. Each word, just remember that in NLP, or when I'm writing, I this movie is good, or how are you, each word is containing separate feelings. Each word has separate meaning and separate feelings. So what is actually language? Language is the set of words or set of feelings through which I want to express my thoughts, through which I want to express my feelings. So what is natural language then? Natural language is like when I'm saying that I'm speaking here now, so this is natural language, this is coming out naturally. This is through my emotion, what I am trying to say. I don't need anything, any external force to create this language. So this is the natural language. So in NLP, we process that. What is the NLP? Then what NLP does? When I'm speaking you some, when I'm telling something to you, or when I'm sending a message to you, the task of NLP is to clone human brains, that portion which actually analyze our speech, our text, and any type of language. So the task of the NLP is that only. So it is not only belongs to computer science, it is belongs to linguistics also. So in linguistics and information science and cognitive science also, it is belonging to NLP. So NLP is belonging to all those fields, not only in computer science. So NLP is not that much easy task. Why it is very much harder? Because when I'm trying to say, suppose think about any sarcastic comment. So as a human, I cannot understand that what the person is trying to say through the sarcastic comment. But I'm expecting the meaning from the system, right? So this is the main task. This is the main, actually the main critical portion in NLP. And another is there is so many ambiguity. I'll be coming later. Okay. So levels of NLP. In NLP is comprised with either speech or text. So if it is a speech or if it is a text, how will we do that? How will we process everything? So if it is a speech, So anybody has worked in speech system, digital speech recognition or digital speech processing? How will you process one speech?
I think you convert it to NFCs,
What is synapses?
names, spectrum, frequencies.
Okay. So if it is speech, then we have to analyze. So how the speech is coming? Suppose when I am saying, how the first you have to know that how the speech produced. When the speech produced, every people has the vocal tract to produce the speech, but the structure of vocal tract are different. That is why we can understand the speaker through the speech, because since everyone's vocal tract structure is different, so one main feature will be there in the speech. Through that we can extract, we can identify the speaker through the speech without seeing the speaker. So what is the speech? Then how the speech we will analyze? So when the speech will be coming, we have to analyze the phonemes, phonetic analysis. Phonetic analysis is like when I am saying what, when I'm saying what. So when I'm saying what, first when I'm pronouncing what, so first I am pronouncing that wo. But like this is actually phonetic. Not this. When I'm saying this word, actually this word is not going directly. It is comprising with that. So we have to analyze that this phonetic analysis. Through this phonemic analysis, we have to analyze this, what I'm trying to say. And if it is a text, then in the case of text, when I'm saying that what are you doing? So this, who is listening my speech, or to whom I am sending the message, the person, this is not possible for any person to understand the meaning of a sentence at the same time. Actually our human brain works in this way. When I'm saying what are you doing, at that time the human brain analyze word by word, not the whole sentence at a time single word. So when I'm saying what are you doing, so first brain will analyze this, then this, then this, then this. After finishing this, then the brain will merge the meaning of each sentence, and then the brain will create the original meaning of this whole sentence. So that is called tokenization. In the tokenization field, we first tokenize word by word. There is another approach, character by character. Character will be very much difficult. Character will be later. Another is OCR. OCR is like, having anyone has worked with PyTest. So PyTest is for OCR. Did you use for OCR or PyTest? So, so OCR is like, if any image is there, and inside the image, if any text is existing, so that is, so through that, so through OCR, same we have to extract the text, which text is existing inside the image. So after getting these phonologies, after getting the tokenized or words, then we will go through this process: morphological analysis, syntactic analysis, semantic analysis. So what is morphological analysis? Morphological analysis, these three steps, actually these four steps are only to use to extract the information, extract the extract the meaning, okay, and to create the knowledge graph in our human brain. Okay, so through that, see, the morphological analysis, it is responsible to extract the to extract the relation between words in morphological way. Now it will be coming syntactic analysis. Sometimes we have seen after typing the code, we have seen that syntax error. Why this? What is that syntax? What is the syntactic? Syntactic is like, suppose I am writing this, what are you doing? If I would write, what you doing? So you can understand as a human, you can understand the meaning that what I am trying to say, that what are you doing? What are you doing? But according to the rule, since R is not there, so it is syntax fault. Fault is in syntax, right? So this is the task of the syntactic analysis, is that to analyze that syntactic structure. Then it is semantic interpretation and discourse processing. Semantic interpretation is responsible to extract the relation. What are you doing? What are you doing now? In semantic interpretation, what it will do, it will extract the relation between what and are, what and you, what and doing. So it will extract the relation between each word, between two or multiple words, it will extract the relation. So discourse processing, after getting all of these, now it will merge the all meaning, all the feelings. When I'm writing this, what are you doing? Actually, each word is containing separate meaning. So after getting the all meaning, we that will merge. So that happens in actually NLP. NLP also doesn't work the full sentence, the whole sentence at a time. It also works word by word. After extracting the meaning from each word, then it will give you the total meaning. So in NLP, we have saw this term information extraction. What is this information extraction? Information extraction is to extract the information from the sentence. Suppose I am saying, I wrote that X is in London. So many informations are there. First is X. Then, this now. Then, London is there. So this is also one information, this is also one information. So, but the type of the informations are different. So we, in information extraction, we extract this information. So which part is responsible for which type of meaning extraction? So that are the these types of are there. One is template filling, another is knowledge base. In knowledge base, we use name entity recognition, co-reference module, and relationship extraction. So this is the most important task in NLP. What is knowledge? So first we will go to name entity recognition. So when I am saying that X is in London, so how would you know that which is name, which word is identifying one name? I don't know. I have no knowledge about. I am not trained, and I am not using any library also. I am not using Spacey. I am not using NLTP, anything. But you have to train the model to identify which word is identifying the name without using any library. So how brain works actually? So then it will, you can apply deep learning approach, you can apply machine learning approach, you can apply another statistical. But what you have to do in pre-processing stage, the main task is the pre-processing, right, in ML. So what you have to do in the pre-processing, first you have to extract the name. How will you extract the name? Because I know that X is in London. As a human, I can say X is a name, London is a name. But how would I train the model in that way that the system can identify that X is identifying one name and London is also identifying one name. So many algorithms are there. So the simplest algorithm is, if you apply parts of speech tagger, that is another task. If you apply parts of speech tagger, from the parts of speech tagger, we know that nouns and proper nouns, they identify the names, right? So from that, we can identify the name. But so many algorithms are also there. Deep learning algorithms are there, ML algorithms are there. We can do that easily. Now the co-reference. Co-reference is, so I know that X is in London. In this sentence, X is the person name and London is the place name. Now I am saying, who is there? Now I'm saying I'm questioning you that who is there. Who is there? So how system will answer? Because I didn't give any name here. So how the system will give the result? So this is coming under co-reference resolution or pronoun resolution, whatever you can say. So the actual, if you see, these two sentences has one semantic relation. They have co-reference resolution relation. Which type of? There is indicating the location. Okay. So how is it is happening? That is also coming under. So X is in London. Full stop. He is my friend. So he is identifying X. So this is coming under co-reference resolution. And another is relationship extraction. Relationship extraction, I just told you one thing. And so many relationships are there. There is hypernym relation, there is syntactic relation, there is a relation, is a. This is one relation name, is a. This is one relation. Okay, like when I'm saying that I am standing here, I am standing in ultimate building. So the relation between me and this building is I am standing here. So the relation is standing. Here the relation is standing. So if I create the graph so that I can easily create the graph so that human brain also extract that relation. So here the relation is standing. So this is one type of syntactic relation. Okay, like that hyponym and hypernym relation is also there. Hyponym relation is like if I say apple is one type of fruit. Apple is a one type of fruit. So here fruit is the hypernym of apple and apple is the hyponym of fruit. That is also one type of graph. So this is the hypernym and hyponym relation. Okay. And there is another is the table extraction, table information extraction. You have to extract the data from table and you have to extract the tables also. Comments extraction, terminology, and audio extraction. Audio extraction is coming with the speech. Okay, so tea break. Please go. No, semantic, see, there are so many relationships. Like this told me relationship extraction. Yeah. Okay. There are multiple relationship extraction algorithms are there. So based on that, they have done this morphological analysis. It only doesn't extract the relationship. It will extract the meaning of each word also. Okay. Morphological, yeah. Meaning of words and after getting the meaning, you can easily relate two words, right? Okay. Yes. And so in relationship extraction, there are so many relationships are there. Not only this is standing, so many relationship extraction are there. So all of them are coming. The syntactic, this is also one type of relationship extraction. Okay, so suppose you are saying I'm standing in the building. So building and you, the relationship is standing. So it's under semantic. Yes. So if you say like apple is one type of fruit, I just told you. So this is hypernym relation. Yes. Like that. So and another one thing. So what is neural actually? What is neural? Deep learning. Deep learning. This is actually cloning the neural architecture. I'll explain how to use. I will not explain.
That's my answer. So I don't want to disturb you for the time also. Okay, no problem. So you can ask. So actually the DL, so I will not explain DL full because I don't have that much time also. Okay, okay, yeah, understood. So I will explain that part only, which will be useful in NLP. And when we will go for this workshop, then I will explain clearly what I am using there. So live coding is also be there. Yeah. Thank you. After completion, we will share. Happy?
Okay, so everybody's in here. 11:50 will start. Okay, so I'm going to start again. Everybody is here. So this is an example of information extraction. I just explained what is information extraction. So this is the example of information extraction. So when I'm typing that Barack Obama was born in Hawaii, so this is one type of unstructured data. So why it is unstructured? Because we have just written the sentence, but we don't know the relationship. What is the structure actually? Structure is that the relationship should be transparent to the public between two words. So in this case, in this state, we don't know what is the relationship and what are the intent, what are the entities are there, and which type of names are there. Nothing. We don't know anything. So this is that is why this text is called unstructured data. Any text is unstructured data because NLP is full of unstructured data. There is no structured data. NLP is full of unstructured data. So from the first task of NLP is you have to convert unstructured text to structured text. Now I'm going, this is unstructured data. So now I'm extracting the information and I'm going to this. So I have here two relations. Was one relation, another is was born in another relation. So if it is was, so what will be the another node? So Barack Obama, I know that Barack Obama is the name entity. It identifies one public, one person name. So Barack Obama is one node, and was is the relation here, and what will be the connected? So two relations was and was born in. Was is connected. Barack Obama was born. So born is one type of entity. It is just the activity. One type of activity. It identifies the activity. What is going to happen? What happened? The incident. Another relation is one born in Hawaii. So Hawaii is the place name. So Barack Obama is the person name. Hawaii is the place name, and the relationship was born in. So this relationship extraction. So how will you extract the relationship? So from the sentence, if I want to extract the relationships, how will I extract the relationship? First, if I will apply the parts of speech tagger, if I apply the parts of speech tagger of this sentence, then I will get to know that Barack Obama is the noun, was is the verb, born is the verb, in is determiner, and how is another noun. Whether it will be proper noun, since H is in capital, it will be proper noun. So many libraries are there to extract the nouns and verbs and the relations and the entities. But some problems are also there. Some problems are existing there also. Which type of problem? If you will write however, instead of capital H, if you will write small h, those libraries cannot identify that as an entity. Why? Because they have hard coded like in that way. If it is a capital H, then it will be coming as a proper noun. So since it is a proper noun, that means it will identify one name. But if the who is typing this message, if the author will not write capital H, if the author will write small h, then what will happen? So we have to first we have to create, we have to build one proper parts of speech tagger. And first of all, parts of speech depends on the context of the sentence, depends on the situation of the sentence, and depends on the environment of the sentence, in which environment you are typing the sentence or you are speaking something, you are saying something. So parts of speech is also fully dynamic parts of speech tagging, but it has already solved. So how to do that? So after applying the parts of speech, so I know that the names, so in a knowledge representation or in a knowledge graph, the nodes contain the nouns, and sometimes some entities which are verbs, but it depends on the situation. So when I'm saying Barack Obama was born in Hawaii, so Barack Obama there is a noun and Hawaii is also a noun. So was born in the relationship. How will I extract that? Was born in will be coming as a relationship. So after applying the parts of speech, when this is coming Barack Obama as a noun and Hawaii as a noun, and these two nouns are connected with this set of strings, where this was is also a verb, born is also a verb, and in is the determiner. So this verb and determiner cannot create any entity, cannot create. This is the rule. So this is the parts of speech rule, that those verb and determiner at a time cannot create any node name or cannot create any entity. That's why this Barack Obama is one node and Hawaii is another node, and they are connected with this was born in. So this is one type of knowledge graph. So this is the structured information. That is the unstructured text. That is the structured text actually. So because I know that which is the intent, sorry, which is the entity and what is the relationship is existing between those two entities. So this is the structured set. So this is the main task of information extraction. Now I'm coming to sentiment analysis. Sentiment analysis, here I have given only the outer, like positive and negative. But I a few times ago I told you so many parts are there in sentiment analysis. So sentiment analysis is yeah, actually we use sentiment analysis to identify the intention of the customer through the review, through the review or through the speech. So suppose this is an example, just normal example. Suppose one mobile is there. So attributes are there like battery, years of use, price, camera quality. So these are these comments and reviews are there. So this is positive, this is positive, this is positive, and this is negative. So how it is happening in sentiment analysis? So not only from the comments, we have to identify the sentiment from the rating also. Suppose if the user will give the rating, one rating or two rating or three rating, from that rating also we have to identify the sentiment. So in this sentiment analysis, I am just showing the outer structure of the sentiment analysis, positive and negative. So these are the positive and this is the negative. So there is another thing is there in outer sentiment analysis also. If you want to know either this is positive or this is negative, in that case also one is there that is called aspect classification. Aspect classification is like if I say the battery is good, but the screen is small. So in this case, what will happen? I am saying that the battery is good, but the screen is small. So what is the sentiment of this sentence? Can anyone tell? Yeah. But if I say, then what is the sentiment of battery? It's good, but what is the sentiment of screen? It's negative. So that is in aspect classification. In aspect classification, we have to extract that thing about which thing the customer has given the review. So battery is good, but the screen is small. So the customer is the positive to the battery, but negative to the screen. So that is the aspect classification. That is also coming under sentiment analysis. We have to do that is we have to apply the aspect analysis or aspect classification. That time we have to use this information extraction, because without information extraction, I cannot understand. No one can understand that about which topic that the user is going to give the review. Okay, so in that case also we have to use that, and that aspect classification will be coming under emotion analysis also. At the time of when the system will analyze the emotion, at the time also aspect classification will be coming. Now the machine translation. So machine translation is, this is called you have seen so many places either machine translation or neural machine translation. So in the case of machine translation, I can say that this is one type of sequence to sequence architecture. Okay. So in this machine translation, the advantage of the machine translation, the people, the person, anyone, any person can understand another language without knowing about that language. The person can translate through the system. Suppose in Bengali, I have written one thing. So if any Bengali was there, so that Bengali can understand what I have written. But if I want to translate into English, then it will be translate that I am working. So this is machine translation. So from the Bengali, this translator is translating to I am working. So why this name machine translation and neural machine translation? The topic is the same, so which type of algorithm we are using, based on that people are giving the name. Okay, so this is actually automatic, and it will help any user or any person, any people to understand different language without knowing the syntax structure, without knowing the semantic relationship of that language. And another is machine translation part. And in the machine translation, what we have to do, suppose here there is a Bengali word, so I am just replacing these with the English. So in machine translation, almost sometimes the input length and the output length may be same and may be different. So in machine translation, we just replace the unknown word with our known word. That we do only. Now, in language technology, there are three things are there. One is mostly solved, another is good progress, and that is not solved or still not solved. Scientists are going solving those issues. Mostly solved is spam detection. Everybody is familiar with spam detection, right? And partial speech tagging. Now partial speech tagging is also working very good. And since partial speech tagging is also working very good, so name entity recognition is also working very good. But good progress, it is working good, but some problems are there in good progress, like sentiment analysis. Because in sentiment analysis, there are so many diversity is there. Sentiment is also depends on in which environment you are typing the review or you are saying something, in which environment and in which and in what which type of words you are using. That is also coming under sentiment. So sentiment analysis, if you will go to analyze only the positive, negative, then it will work, because that is coming on only the normal text classification. But after that also, the system cannot identify sarcastic reviews, sarcastic comments, that this comment is belongs to positive or negative. Okay, and that is co-reference resolution. The main drawback of the co-reference resolution, the problem of the co-reference resolution is, first you have to extract that any name is existing there in that sentence or not. If the name is existing, then I have to identify this name is belongs to the person or this name is belongs to any place, or which type of name is this. So after extracting the name, I should know that which type of name is existing there. After getting that information also, suppose I know that Raghu is the person there. After that, I should know this name belongs to male or female, which category this name is belongs to, because after that only I can use this his. If this Raghu is belongs to male name, that time only I can use his. Otherwise, I cannot use. If the name belongs to female, I cannot use this his. So the main problem is there. Any people can give any name to their child, to any person. I can so some people has given Raghu as a male name, but another person can give as a female name. So in that case, this co-reference model will not work. Suppose if any person has given the name Raghu to any object which is not person, but it is like any town name, any city name, any place name. So at that time also I cannot apply this is her. We cannot apply. So in that case also co-reference resolution model will be failed, will not work. That is why it is not mostly solved. It's working good. And machine translation, I just and another is word sense disambiguation. The sentence is the mouse is very fast. So we know two types of mouse. One mouse is electronic gadget, another is animal. So it is very much difficult to understand that from this sentence which mouse am I indicating. It will be very much difficult to understand. But based on your data set and based on your pre-processing algorithm, you can identify. But after that also it will be very much difficult. So many like apple is fruit is also there, and organization is also there. So it will be very much difficult to identify which apple I am going to indicate, either fruit or it is an organization. So that is called word sense disambiguation. Now it's coming information extraction. I just told that I am in Chennai, so it will extract the Chennai. But why it is also difficult, because in information extraction, I told you that POS tagging is solved. Actually, partial speech depends on the environment, depends on the context. Partial speech tagging is working good nowadays, but if any case will occur where partial speech will be failed, at that time, intent extraction will also be failed. So people is working on that. Another is text parsing. Actually, when I'm typing something, I'm in Chennai or Barack Obama was born in Hawaii, whatever. So actually, in text parsing, what happens when after typing the sentence or after speaking anything, it represents internally in a parse tree. So how it represents that parse tree creation is also one type of very difficult task. In the case of when you will go to create parse tree, at that time you have to use some grammar rule. I think in college, in computer science, you have studied about context-free grammar. Have you need to know context-free grammar, CFG, like those? So those that type of rules we have to given, but there the problem is that there is no specific rule that in this way you have to write the grammar. There is no specific rule. So multiple user can write multiple grammars. That is the main critical task in NLP, because so many ambiguity will be there. I am creating the parse tree in this way. Another person can create the parse tree in another way. So that person parse the structure of that person's parse tree will be different from my parse tree, but the sentence will be the same. So actually, there are so many ambiguities will be there. Because of that ambiguity, NLP is the most critical task still, and that is coming under not solved. Those portion is coming under AI hub or NLU, and NLG is also there. So first is question answering, like that. One paragraph is there. Based on the paragraph, one question is there. So based on the question, you have to search that which type of answer, which answer may come. Based on that, it is giving the answer. Next is coming text summarization. Text summarization is Like if I give you one document which has 50 pages, 50 pages document, so you have to summarize and you have to create one small document which will identify that 50 pages document uniquely. So that is also one type of NLU task, and it is also solving text summarization. Another is conversation, that is called conversational agent. So someone is asking a question, another person is giving the answer. Now I'll say that why NLU is difficult. So how the ambiguity is coming. So this is one the actually in language when I'm writing anything or when I'm saying anything internally, it creates one parse tree. I just told so the hidden structure of that of the parse tree, the structure of the parse tree is very much ambiguous. How is that? Suppose this is a sentence. So from that sentence, I create one parse tree. So this parse tree, I have created this parse tree through some grammatical rules. That this is the start symbol. From that start symbol, I am creating NP and VP. NP is the noun phrase and VP is the verb phrase. So in NP, there are another is there NNP. So under that this name is coming based on this grammatical rule. So I have given the grammatical rules that based on that rule it has created this person. And now another person will come and that person will give another grammatical rule. So at that time the parse tree will be created. The parse tree will also be created and the meaning will also be the same, but the structure will be the different. So this is the ambiguity. Same thing will be there, but I mean same meaning will be there, but the structure will be the different. Like why this is ambiguous? So the cause of the ambiguous because parts of speech works on the based on the context. So if the context will change, if suppose I am saying this, Fed raises interest rates 0.5% in effort to control inflation. If I say this, in which way I am saying this, based on that also, personal speech tagger will tag each word. So sometimes according to the context, sometimes it will give noun, sometimes it will give verb, sometimes it will give noun, verb, and verb. This is plural plural, verb singular, and rates also noun singular. This is duty. So see, same word is coming under multiple parts of speech. Same word is coming under multiple parts of speech. So based on my rule, suppose I have chosen this NNS. I have chosen all these two. So my structure, my past structure will be different. If another person will choose this, if another person will choose this. So the past will be the different. So since parts of speech ambiguities are there, that is why the past structure will also be ambiguous. So and another meaning is there. Suppose interest. So there are two meanings of interest, right? One is to increase the money. Another is interest is if I have any feeling on something, if I want something that I have interest on this laptop. So interest means multiple types of words. So since one word has multiple meanings or multiple feelings, so ambiguity will be coming easily. And the main task of the NLU is to understand the natural language, to understand the perfect meaning. So if one word has multiple meanings, it will be very much difficult to extract the original meaning. That is why this ambiguity is coming. Now, see the example of ambiguity. Here I am using this past say Fed raises interest rates. See the its past see its past. Fed raises interest rates. This and this for about the 0.5%. I am adding this later. Just this. This is the difference. Yes, Fed raises interest rates. The structure. So same sentence, same meaning, same environment, but the parts tree structures are different. So because of that, because of these ambiguities, MLB is coming very difficult. Sir, oh, CD is like ordinal digit. It identifies only the numbers. If you give 2, 3, like only the numeric values. Okay. Now the parsing. So what is the parsing actually? So now from that time I was saying that parsing. So what is the parsing? Parsing is we have to apply some grammatical rules to represent the sentence, to represent the word, to represent my speed internet. Because if I give a raw text, if I give the unstructured text that I am staying in Chennai, if I give that unstructured text to the computer directly, the computer cannot understand what I am saying. So I have to represent some. Yeah, I have to represent. I have to create one burst. I have to create one tree. I can create one graph, whatever. But I have to give the meaning what I am trying to say. So we will apply grammar rule to find possible structure of a sentence, and actually there are in parsing there are two things same as in computer science also. One is bottom up, one is top down. So actually what is bottom up and what is top down? Top down is like suppose few times ago I get that this, suppose this, if I want to create this from top down, so I have to give the rule like that. S is the start. S is the start. Inside S, I am giving the rules. First, noun phrase will be there and verb phrase will be there. Nowadays, noun phrase is coming. Inside and under the noun phrase, there will be there noun plural. And inside under that noun plural, this name is there. So top down is like from the start to end. You know what is your goal in the case of top down. So you have to create the first way. You have to apply the grammar rule in that way. In which way that in that way actually the parse tree will be followed. But in the case of bottom up, so the bottom up is little bit difficult than top down because in the bottom up you have to create the whole sentence from each word. Suppose from this word you have to create this. From these two information, from this information you have to create this. From this information you have to create this. From these two information you have to create this. Like this, this is bottom up. This will at the end of the time, at the end of the parse tree, in the case of bottom up, you will get the whole sentence. And in the top down, you will get in top down, you will from S, you have to give first A start symbol. From that, you have to create the first tree. And from bottom up, you have from the leaf nodes, you have to create the main sentence. That is called first. Now context-free grammar. So in context-free grammar, we have to maintain some terminology. So suppose G, if I identify grammar with G, then G equal to, I can say that this called tuple. So T, capital T, capital N, caps S, caps R. So what is caps T? Caps T is the terminals. And capital N is the non-terminal. So what is the terminal? So if you think about the normal English meaning of the terminal, that which has which is the leaf actually. So that identifies the terminal. So like in that in this parse tree, if I think the first parse tree, so one is there G equal to T N S R. So T is the terminal, N is the non-terminal, and S is the start. So I am starting from S. Then I am giving the non-terminals. Non-terminals must maybe the parts of these phrases NP, VP. NP, since it is a non-terminal, so it should have any child, one child or multiple children. So this is the rule of non-terminal. So since you are mentioning that this phrase or this word is the non-terminal, that means you have to give one or multiple children to that phrase. So non NP is a noun phrase, and I'm saying that this is also non-terminal. So under that NP, I'm giving N. N is also non-terminal. I'm giving fed. Now fed is the terminal. How will I know that this is terminal, this is non-terminal? For this, uh, for this identification, for the sake of simplicity of this, we have to maintain non-terminal is in caps lock. NP and VP, NP is also in caps lock, VP is also in caps lock. If I write like that, yes, NP small form, then it is terminal. It is not non-terminal. So if you want to maintain non-terminal, if you want to identify this is non-terminal, so that should be in caps lock. So N is failed. Now I'm coming. So N is since N has is reached this portion it has reached to the terminal. So under the Fed doesn't have any Fed should not have any child or any number of children. Now it will be coming VP or verb phrase. Under the verb phrase, I am getting verb, another is noun phrase. Under this V, I am getting again phrases. So again it has reached to terminal. So we will stop to iterate this. Now NP again. Under that NP, based on this is the context free grammar rule, and R is that rules that you have to give the rules. This is the set of rules. This is the set of rules, and R is identifying this rule. So this is S is the start symbol from where it will start, and whatever it will generate, it will be the grammar. The grammar G generates a language. So language is the set of grammar, set of words. So when you are typing that what are you doing, it is maintaining one grammar rule. Based on that rule, after that only it is creating one language. Now this is one example that the teacher praised the student. So how I have created this in that way only. So this is the start symbol. From that, I have created noun phrase, verb phrase. With this rule, I have created this past tree. If someone will come and if that person will give another grammar, you can give here another also. You can give here another NP, another VP, whatever you want. So the past tree structure will also be different. So but the meaning of the sentence and the sentence will be the same, but the structure of the past tree will be the different. That is the ambiguity here also. Okay. Now I'll go to deep learning, which I will not go through the whole deep learning. I will go through those parts which are helping in NLP. Okay. So this is not properly deep learning. I am just explaining that what is sequence to sequence model and why we are saying that these are the sequence to sequence model. Okay. So when I'm typing anything, when I'm giving any query, any question, or when I'm speaking anything, this. So what are you doing? See, this is a set of words. So this each word is nothing, a sequence only. That is why this is the sequence. This whole sentence is the sequence of words. So why I'm saying this sequence to sequence model? So when I'm asking someone, what are you doing? According to that question, someone will give me the answer. So this is one sequence. From this sequence, I will get another sequence of words that will be the answer. So that is why I am saying there is sequence to sequence model. So there are so many types of sequence to sequence models are there. So I will be coming each of I will explain all the types. So first is that so today we will do conversational agent. So that is coming under many to many, that is coming under many to many sequential model.
The previous slide.
Uh,
Also the previous.
that I do the screenshot.
That under VP and NP, but you write the rule VP under VP.
Under VP. Okay, sorry, it was mistake. N and NP, instead of N I wrote V. Thank you. That was mistake actually. Okay. So see, I took this screenshot from one lecture. So I had to explain that what will be the examples of sequence data and what is the sequence data and what will be the example of sequence data. Whoever has watched Andrew MG's lectures, I think those person has watched and got this screen. Okay. So first is, so these are the sequence. This is some examples are in sequence model. So many examples are also there. So today we will go for conversational agent, which is not there, but that is also one type of sequence to sequence model. Okay, so first is speech recognition. Okay, I will go through each type. So there are so many types of sequence to sequence model. So first is, if I go to many to many. In the case of many to many, there are two types. It has another two types. One type is, in that case, length of the input will be equal to the length of the output. So that is coming under speech recognition. That is coming under speech recognition. This is length of input equal to length of output. It is coming under automatic speech recognition. Why it happens? So actually, what is many to many? See, when I'm talking about sequence to sequence model, in the sequence to sequence model, each sentence or actually each word is also one type of sequence model, because each word has created by the sequence of characters. So when I'm talking about the sequence to sequence, so suppose each sentence is the set of words. So it is also one type of sequence. So when at the time of automatic speech recognition, what it does actually in speech recognition, suppose I'm saying that I am standing here. So the system will identify what I am saying. I am standing here. System will not add any extra word. System will not delete any word from that. System will just convert what I have said now. So I am standing here. So the length of this sentence is 4. I am standing here. So system will give the output what I have what I have spoken here, that I am standing here. So the output length will be the 4. So the input length and the output length will be the same in automatic speech recognition. And I just showed that in machine translation also sometimes it happens where input length and output length will be the same. So this is one type of sequence to sequence model, and another is there inside many to many, where the input length is not equal to output length. That happens in conversational agent. Sometimes it may be equal, sometimes it may not be. So actually in the conversational agent, when I'm asking what are you doing, so the length of this 4. So suppose that person is studying. So person is replying. I don't know that in which way the person will give the reply. So the person can give the reply, I am studying, or only studying. So the input length is 4, but the output length it may be 3, it may be 1, and it may be 4. I don't know. Okay, so sometimes that is why sometimes input length not equal to the output length. But in the case of speech recognition, it will be the equal, because the system will not add any extra word and the system will not remove any word from the sentence whatever I have spoken. So but in this case input length may not be equal to the output length. So that is coming under many to many. Another is many to one. So sentiment analysis is one type of many to one. sequence to sequence model. How it happens? Suppose I'm saying that the movie is good. So the movie is good, the length is 4, but its sentiment is 1, either positive or negative. So the input length is 4 and output is I'm getting 1, strictly 1. I will not get positive and negative, I will not get that. So I will get either positive or neutral or anything, whatever, or angry or happy, whatever. So this is coming under many to one sequence to sequence model. One is one to many sequence to sequence model. That is music generation, or that is sometimes under this one to many energy also come natural language generation. Not only music generation, sometimes it may come. If I give you one word, suppose cricket, and I have given you this word cricket, and I say you that you have to create one sentence or you have to write one paragraph on this word cricket. So your input is one cricket, but the output is the length of the output. It may be one, it may be n. So that is called one to many, and one to many has another some modules like one to one. If I give you one input and if the output is one, that is one to one. But maximum time it happens one to many, because if I say you that cricket and you have to write a paragraph on cricket, so the input length is cricket, the input length is one, and the output length it may be 50, it may be 100, I don't know, whatever it may be. So this is called one to many. So these types of sequence to sequence models are there. Okay, so after that, now we have so many statistical algorithms to classify the what I am speaking. Now I am purely talking on NLP. I am going to purely NLP. So I will speak on NLP only. So suppose I have given you one speech. So in that speech, if I tell you what I have spoken, you have to recognize. How will you recognize? So that is coming under automatic speech recognition. So how it works actually, automatic speech recognition? In traditional method, what they used to do in automatic speech recognition, after getting the speech, after actually in traditional method they didn't have that type of data set, and they didn't, actually before I'm talking. So what they did, they used to, after when I'm speaking one sentence, after speaking the sentence, the system will take the speech and it will analyze like that. Suppose I'm saying I am in London. Sorry, I'm staying in Chennai. So what will happen? First, so speech is nothing, is a wave, right? It's a signal only. So it was trying, the system was trying to split the according to the wavelength of the speaker. Suppose I am saying I am staying in Chennai. So they know that what will the peak value, and what the peak value may reach when I'm saying the I. So based on that, suppose this is the graph of my, when I'm saying I'm staying in Chennai. Okay. So when I'm saying that I'm staying in Chennai, how it happens? Suppose it is starting. So it is digitization, right? First we have to convert analog to digital. So this is so many. After the converting analog to digital, it will be coming in that way. So when I'm saying that I'm in Chennai, this is coming as a analog signal, but after that it will convert to digital signal. So after digitization, this looks like this. So when I'm saying I, so that system, what they used to do, they used to select those portions where I may exist. I word may exist. Suppose this portion. So in this portion, I may exist. So I cannot say clearly, right? I am saying that I am staying in Chennai. So I and am, there is some silence region is there, unvoiced region, that is called, in speech recognition, that is called unvoiced region. There are so many regions are there. One is unvoiced region, one is silenced region, one is voiced region. So, but unvoiced, sometimes unvoiced region is equal to the silenced region, but it doesn't happen every time. So this is the I, then I paused. So some silence region is there. Suppose purely silence region is not possible because 100% effectivity, 100% is not possible. So something noise will be there. Suppose this small. So since there I didn't say anything, the peak will not be increased. So this is the silence region. Then I am saying am. Suppose this is the am. So based on, so they used to do in this way. They used to identify. They try to identify that this region may contain R. This region may contain M. This region may contain staying in Chennai in that way. But the problem is it possible to identify the proper region that in this region I is available? It is not possible. So what they did after selecting the region, they used to extract the features. So what will be the features then in speech? In speech, they used to take like the maximum frequency, maximum frequency, another is minimum frequency. From that, they will calculate the average frequency and frequency as over. And another something was there, how many samples are there, how many digital values are there. So after calculating all of these things, they used to feed their model, and the model trained, and the model got trained with this type of data. After that, they test it. So they used to use hidden Markov model. Yes, and still hidden Markov model is very good in speech recognition. But the problem is in speech recognition, actually in speech recognition there are so many problems because everyone's accent may be different, and since especially in India so many communities are there, so their pronunciation style, their accent, everything will be the different. Another is since our vocal tract structure is unique, everyone has unique vocal tract structure, so their features will also be the unique. So for those, all of these factors are there, that is why those speech recognition model used to fail. Now what are they doing? After getting the speech that they apply, and now they are trying to clone our human ears, how we listen the speech. So we have 5 sensors. In this case, they are trying to clone how we are listening some sound. Not only the speech, any type of sound. Suppose if I'm typing here this sound also I am listening. So I am identifying when this sound is coming, that means someone is pressing one key. So now the scientists are cloning our human ears, how we are listening. So after cloning that, that algorithm we told NFCC, this NFCC has cloned our human ears. This algorithm has cloned our human ears. So how we are listening. Another is there, LPC. LPC has cloned our speech system, how we are speaking. But in the case of when speech recognition is coming, it will be more actually advantage if we clone the human ears. Because suppose someone is speaking, so what I am listening, according to me, that is the speech recognition. So that is why this MFCC will be the more useful. In some cases, we have to use this LPC. LPC clone our speech system, how we produce the speech. Actually, when the speech produce, vocal tract just vibrate, nothing happens, no sound, nothing. When it comes out from the human body, at that time only, through which medium this is coming out, based on that the sound is adding. So but vocal tract doesn't add anything. So but seeing the structure of the vocal tract is unique, that is the style of the vibration will be the unique. The style, seeing the style of the vibration will be the unique. That is why based on that feature, we can identify the speaker without seeing the person. Only after listening the voice, we can identify the speaker based on that unique feature that is coming from because of the vocal tract. Because vocal tract is unique. So it happens. So after applying the MFCC, we will get the set of features. So after getting set of features, now we have to create the architecture. So now we can use any type of classifier. We can use human Markov model, sorry, hidden Markov model, or we can use RNA, we can use LSTM, we can use hearing, whatever we want. So first main thing is we have to apply this MFCC properly. So after that, now when I will go to build the architecture, how will I build the architecture? There should be some factors will be there that based on this. Actually, it is not random that I will just type some TensorFlow code and I will just create LSTM and or GLU. I will choose whatever I want, or either RNN or LSTM or GLU. So there should be some factors will be there. I have to check that what is the size of the sequence, the length of the sequence. Okay. So based on the length of the sequence, I have to choose the classifier based on the actually the length and the relationship and the features. We have to select the classifier. For that, I am going to create RNN or LSTM. So in deep learning close the human neural system. But since no one knows how single neuron works, that's why deep learning is also not perfect. But they have reached in some point. So in NLP, we use RNN or LSTM, but nowadays people are using CNN also. Because CNN actually people used to use CNN in computer vision or image recognition. But CNN is very good to extract the feature from characters. That's why nowadays we use CNN to extract the character features for text classification. But now today I'll discuss RNN and LSTM because these are the most popular algorithm and popular neural architecture in NLP. Okay, so first LSTM or RNN. Why we use sequence to why we use RNN and LSTM? Since it is a sequence to sequence model, and I have told you that whatever sentence I am speaking, so suppose I am staying in Chennai, so each word contains unique meanings or features. So in this sentence, all the words are interrelated actually. We are typing with giving some space or we are speaking with some silent region, but they are interrelated. So how they, but in the normal classifier, we used to just give the data set or the patterns, the features. After that, they used to classify. But some problems are there. Some problems are there means when I'm going to extract the name entity. Suppose I have a sentence which has 1,000 words because in English grammar there is no rule that you have to give maximum 50 words or you have to give maximum 20 words. There is no rule. So the customer, the user or the person can write a sentence which has 1,000 words. So when I'm reading the 1,999 word, that time it is not possible for me to remember what was the meaning of the first word or what was the meaning of the 10th word, right? So to solve these issues, they had to write some neural architecture. So they came first RNA. So in the RNA, so they tried to clone the neural structure through RNA. In the RNA also, they used to do, suppose this is the RNA, this is the first input value x of 0, this is I am getting y, another is there, x of 1, that is only 1 like that. So from here, so this is the first word that I'm saying. I'm staying in general. So I will be the first word based on this I. What will be the probability that second one word am will be coming? So after getting this I, this will give one probability I one value, and it will give one value to this, that is called activation function. So it will give the value this, and here what will be the actually what will be the percentage, what will be the probability that second word amp will be coming, because I'm saying that I am staying in Chennai. So based on the previous value I, what will be the probability that second word am will be the coming? So suppose there is a almost one probability is there, I'm assuming. So I am now, what will be the probability that third word staying will be coming? So I have already got. So what will be the probability that third word staying staying will be coming given I am. This is conditional probability, right? So what will be the probability that staying will be coming after getting this I am? So after getting this I am, suppose I am assuming this probability is also almost 1. I'm saying that just assuming. So now it will be coming fourth word. How it will be coming? That in will be coming in a fourth position after getting these three words. I am staying. So now see, now it is working good in sequence to sequence model, because here I am able to interrelate between multiple words. But now the problem is coming when it is coming. So here, if I want to extract the meaning of this, I am taking only the help from these three words. So I don't know the future words, what was there. Okay. So now I'm going to extract the name entity from these two words using RNN, normal RNN, without bidirectional, only one directional RNN. How it will happen? So he said, based on this, he said, I can identify. Suppose this is I have used partial speech or whatever algorithm I have used. Then I know that Teddy is the name. I don't know whose name. Teddy is name. From this sentence, I also know that Teddy is also identifying the name. But I cannot say that which Teddy is identifying the person name without knowing this sentence, right? Without knowing the remaining parts of the whole sentence. So if I go, so from there, I know that Teddy is a person name. But here, Teddy bears are on shape. So this is not the person name. But until I don't have any idea about the future words, I cannot say that Teddy is the person name. So how to solve that issue? So to solve that issue, we should know the meaning of the future words also, which are coming after these words. For that, they have introduced bidirectional. So what is the function of bidirectional? In the case of bidirectional, when first word is coming, so what will be so it is checking that there is no word before he. So it has identified, it has calculated the probability based on its previous word and based on which words are there. This, this. So same algorithm will be applied to each word also. So after that, I can say that this will identify the person name. This will identify the person name. This is not the person name. But now, so that problem is also solved. But the problem, another problem is arising is that if this sentence is 1,000 words long, if this sentence is 1,000 words long and the co-reference is existing there, suppose I'm saying he said Teddy Roosevelt was a great president, to stop some words are all there, and suppose at the position of 990, again I am saying that he was the president. So, so actually he is identifying the Teddy Roosevelt. But when I'm reading that word at 990th position, I already forgotten about this word. What was that? What was the meaning of this word? So I have to store something. I have to store the previous word's meaning in the memory cell. So for that, they are used LSTM, long short-term memory. So in LSTM, they are using some memory, small memory. So it will persist until the sentence has finished. When the sentence is finishing, at that time it will remove whatever has stored in the memory cell. It will remove and it will go to another sentence. But until the whole sentence will be there, so it will work. So that's another problem. Suppose this sentence has finished here, and after that he is coming. So LSTM, when full stop has LSTM will get the full stop here or end of statement, at that time LSTM will remove everything from its memory. So when here full stop he will be coming, so he is actually identifying the individual. But LSTM has also forgotten. That is the main drawback in sequence to sequence. So scientists are trying to solve that issue. So actually bidirectional is coming to know the future words meaning, and LSTM has came to solve the long-term dependency problem. That's called long-term dependency problem. So if at the 990, suppose one sentence is going on 1000 this sentence without any full stop or anything. So at that time, the LSTM will be able to identify that paper who is Teddy Roosevelt and what is the meaning of this word. This is identifying the person. So these are the some basics in neural structure. So today when we go for the works of live coding with this architecture, I'll explain properly. Okay. Now see, actually when I'm saying any word, when I'm writing any sentence or whatever, suppose I'm staying in Chennai, how to represent that sentence in computer? Because ML algorithm or DL algorithm cannot understand the raw string. He needs vector representation or the numbers. So I have to convert each and every type of word into set of numbers or vector of numbers. One vector which will contain the all the numeric value, either it is integer or fractional, that is okay, whatever. So how to do that then? That's some methods are there. One not encoding, and you guys have already heard about what to make model good, what to make model, and what encoding also. And it happens when speech is also come. Not it doesn't work. Not only it works on the whole NLP system in NLG, NLU, whatever is speech is there. You have to convert when I'm speaking something. When I'm saying that I'm saying in Chennai, at that time also I have to convert each word to numbers, to the numeric. That number may be integer, that number may be a fractional. That is not an issue. But how to do that? So, okay. Now you have the data set. Now I'm talking about the supervised. I will not go unsupervised. Unsupervised document clustering I will come later. So now I'm only supervised. So suppose you have a data set. You have a vocabulary. You have vocabulary, not data set. So it is a set of words. So since it is a set of words, all the words should be unique. So no repetition will be there. So I'm saying that suppose some Chennai, Bangalore, B, C. These type of words are there. So how actually in sequence to sequence model, if you want to access any sequence, you can go by two process. You have to choose any single process. One is word by word, Another is character by character. So character by character is the more useful than word by word. But the problem of the character by character is it needs huge complexity. It needs high computational power because think about this sentence. One word encoding. So here in this sentence, only three words are there. So if we will go by word basis, so I have to access three words. One word encoding. If I go by character basis, then I have to access each character. Even I have to think about the space character also because space is also a character that is not a null. So we can go by character, we can go by word. So here where I'm going to word by word. So and even if you have a single word, that is also a sequence because it is a sequence of characters. Okay. So now I'm saying I am staying in Chennai. So I want to process this. I want to create the vector of numbers. I want to create one matrix for with the numbers to represent each word. So first, one processor is one hot encoding. So how do we do that? So you have suppose you have a vocabulary, 1 lakh size vocabulary. So 1 lakh size vocabulary means that vocabulary should contain 1 lakh unique words. No repetition should be there. So if you have 1 lakh size, or if you have a vocabulary whose size is 1 lakh, now you have to convert each word. This is also a word. So each word you have to convert in numbers. How do you do that? So from this vocabulary you have to do. Suppose I, and suppose here is I is there, and so since you have vocabulary of since you have set of words, unique words, each word should have a particular location, particular index. Suppose I am starting from 1, 2, 3. Suppose it has 125. It has 6, 25. It has suppose 1001. So now this is your vocabulary list. From this vocabulary list, you have to create each words. You have to represent each string by numeric values. So how do you create for the I? In one of encoding, what happens? In which position in your vocabulary I is existing? Only in that position we will replace. We will give 1. Okay, so if I is there, the position of I is in your vocabulary 125. So everything will be 0, 0, 0, 0, 1. Everything will be 0. So this position is 125. This is the vector representation of I in one hot encoding. Another will be coming M. In the same way, M will also be coming in under 625, where 1 will be there, another portion will be filled by 0. Staying also same, in also same, Chennai also same. So before it was working good, one hot encoding, because our main goal is to represent each sentence or sorry each word or each character by numeric value. So this is working. But the drawback of this, why this one to and word encoding came, because these are the more complex than one hot encoding. The problem is that suppose in your vocabulary there is a word mango. In your vocabulary there is a word mango. Suppose its size is its index is 2000. In 2000 position, mango word is there. Another is there, suppose, another fruit name, orange. in suppose 10,000. Now you have trained your model in that way. I want a glass of mango juice. I want a glass of mango juice. You have trained your model with one hot encoding. Now you have trained, your model has trained well, everything is fine. Now you are going to ask to the user, sorry, to the model that I want a glass of dash juice. So model has to fill up that blank space, that blank. How the model will do? If you apply one hot encoding, there is, if you see the index of the fruits, these two fruit names, there is a huge difference. In 2000 position, mango is there, and in the 10,000, orange is there. So there is no relation. There is no relation is existing between mango and orange. So how the model will do? So your model will can do. I need a mango juice. I want a glass of mango juice. Suppose you have asked the model, I have a mango juice and I want a glass of blank juice. That time, if you give again mango the model, then the answer is not good. Then you are expecting that it is a orange or another fruit name. But if you see in the vocabulary, there is no relation in mango and orange since their positions are positions are very actually it is in 2008 the difference of their index is 8,000. So there is no relation between mango and orange. So you have to create that type of embedding, that type of model, that type of you have to represent your database, your data set in that way, or you have to at the time of testing also you have to use that type of data modeling where these will be these fruits will be in the same box or will be in the same space so that the model can very easily can switch from one fruit to another fruit because they have the relation that these two words is identifying the fruit. For that, what to make is coming. In the what to make, what happens actually, if you draw a graph, suppose you have huge data set and you don't know and you have to you have to actually have all the similar data in a separate class. Suppose you have a data set of which contains set of fruits, which contains set of uh, animals name, which contains set of people name, so that your model can create three different space. One space is containing the human names, one space will be containing the animal names, another space will be containing the fruit names. So that if you ask the model again that I have a apple juice and I want a glass of blank juice so that the model can easily find another fruit name so that why because in a same space all the fruits name are existing so they have the relation that type of relation and when you are creating the relation between two words or between two objects they have the relational value so based on the relational value the model will choose the highest possible value from that relational set of values and it will extract the fruit name and it will give you the answer. So that is the task of what to fake. But the problem of what to fake and deep learning is in this case you have to give huge number of data set. Otherwise it will be overfitted. Because if you give less data and if your architecture is very good, then it will be trained properly, but it will be overfitted. Because and the problem of the overfit is it cannot test. You will not get the proper result with unknown data. That is the main problem of the overfitting. But we don't want that, right? We want to train the model to get the proper result from the unknown data. But in the case of overfit, that will not be happening. So for that reason, we need to give huge data set for this to create this what to do. One, I told that 1 lakh, the vocabulary size is 1 lakh. Actually, 1 lakh is very minimum in the case of NLP. When it will be coming for the DL, it needs more than 1 lakh. 1 lakh the size, the vocabulary size should be more than 1 lakh. So otherwise, it will create actually. Otherwise, it will not work properly. Okay. So at the time of then we are creating the word to fake. How we are creating the word to fake? We know that in word to fake, they actually separate the similar types of objects in the same class. So when I'm saying that it is classifying, so another definition is coming. What is class? Can you tell me what is class actually?
Class is one type of thing.
Because in AI or ML we say that it is classifying. This is the classifier. So what is the meaning of class? What is the function of classifier? Class is, yeah, like that, but class is actually set of similar types of objects. When I'm saying that this is a class of chair, so that class should contain only the chairs, not the laptop. So when I'm saying that this is the class of laptops, so that class should contain only the laptops, not another things. Like that only, when I'm saying that this class will contain only the person, so that class will contain only the person name, not the human. Sorry, not the food name, not the animal name, anything. Okay. So it happens in actually class. So the task of the classifier is to classify them based on the patterns. So this is the main goal in ML, and this is the main goal in DL also. So DL is the deep learning. Deep learning is the subfield of ML. So in ML, we could solve in ML through actually, if we want to solve various types of problems through ML, we can solve those problems. But the problem of the ML is in the problem of the ML is you have to give so many hand coded features. Hand coded features mean in NLP I'm saying, suppose if I want to extract the parts of speech from, suppose if I want to extract that Barack Obama was born in Hawaii. So if I want to apply ML algorithm, we can apply name-based algorithm. We can apply another for extracting names and extracting entities. So and parts of speech also. In the case of parts of speech tagging, we can apply hidden Markov model also. So in the case of ML or in the case of statistical classifier, the problem is you have to give externally that this word is identifying this meaning, or this word is the relationships between these words are this. So this is actually huge manual processor there. That is what. And another problem of the ML is like if you give everything hand coded, so it will not be fully automatic. Something you have to do manually. So to solve that issue, that they brought actually deep learning. In deep learning, you don't need to give that much hand coded features. You have to give, but not that much uh, like ML. Just give the data set and this so that it will automatically extract the features and it will then classify. But the problem of the deep learning is you have to use data set. So these are this RNN and LSTM. These are the actually in deep learning we use these to for classifying the sequence to sequence model only. So here, see, in speech recognition, I have told that how they are doing the speech recognition problem, how they are solving the speech recognition problem. There are another problem in the speech recognition problem is the noise, the background noise. This will be very much difficult to remove the background noise, because if background noise is existing inside your speech, it will be very much difficult to extract that which frequency is identifying the background noise and which frequency is identifying your own voice. So it will be very much difficult to extract the background noise. Though in electronics and the digital signal processing, they have some modules to extract the to remove the noise, but it is not possible to remove the noise fully. I mean, 100% is not possible. Now it's coming music generation, sentiment analysis, machine translation. Another is video activity recognition. This is called video. In the case of video activity recognition, if I show you one video, you have to recognize what the person wants to do. It's like it's like image captioning also. Suppose if I give you one image of this image that laptop is keeping on this table, so you have to apply the image recognition, and you have to apply the NLP algorithm to say that this laptop is keeping on this table. So this problem is called image caption. So in that case also, sequence to sequence model will be coming, because in the case of image captioning, in that also, when you so the input is one image, that is also sequence of numbers, that is a sequence of features, sequence of colors. So from that you have to identify what is there, so that you have to apply the object detection to what things are there. After detecting the objects, you have to write. So after detecting the object, you have to apply natural language generation to create the sentence that laptop is keeping on the table. Okay, so your lunchtime. Let's go. Okay, after something. Okay, so these are the main things in sequence to sequence model. So now,
At the time of training the data, you take one data set here. Instead of you want to convert word to data, numerical data. At the time of training the data, you are using to count the create time. Why are you using time? Definitely you want to update the value. Why are you using time formula?
okay, no, actually, you can use any algorithm to convert from string to numeric value. Sometimes you have to convert. Suppose you have a set of words. You have a set of words. Sometimes you can use their index also. Sometimes you can use that word to heck also. Okay, and sometimes you can use that one hot encoding also. So in my case, when in my workshop when I go, I am maintaining here, because since I don't have that much data set, so I will not apply word to fake. I will apply that from the index, how to identify the word from the set of vocabulary index. Not in one hot encoding. I will not apply one hot encoding, because if you see the one hot encoding matrix, you will be seeing that this is one type of sparse matrix, right? Because few zeros are there, more than one. So this is one type of sparse matrix. So if you want to maintain sparse matrix, it is okay. But if you don't want to maintain sparse, if you maintain the sparse matrix, you have to use you have to use that much memory to maintain only the zeros. So actually zero is nothing here, right? So zero, we cannot we will not get anything from the zero. But after that also we have to maintain the zero there. So that is why we will not use that also. We will use that from index, from suppose I have this set of vocabulary. So I have each index, right? So I will use this to identify the word uniquely. Okay, because I cannot apply here Shiba, I cannot apply here skip gram, cannot apply here globe, I cannot apply here what to fake anything, because I don't have that much data set. Okay, now, so if any person wants to uh, access sequence to sequence model through character by character. What is that? From the character by character, if I say hello, if I say hello, this is a single word. So in this word, I have 5 characters. So another word is there, hello world. So I have to identify or I have to analyze this whole sequence. This is also sequence. This itself is also a sequence. Why this itself is a sequence? This is the sequence of characters. This is also sequence of characters. This is the sequence of words. So actually, when I'm saying that hello world, I just told you that it is not possible for the human to identify the meaning of a word at a single time. The same thing, when I'm saying hello, when I'm reading the hello word, I am also understanding the each word after analyzing the each character. Human brain is analyzing in that way. Human brain first analyze this is A, this is E, this is L, O. That means it is containing the hello according to our data set. Whatever by which data set we have trained our own brain model based on that. But initially, brain also analyze each character. So it after analyzing each character, it analyze this is hello. So after analyzing this space character, it will identify this is space. After analyzing each character, it will go by word. So hello world. So like word by word basis, in word by word basis, we were maintaining we had to convert each word to the numeric value. But in this case, we have to convert each character to the numeric value. So in that case, we were maintaining one set of words that's called vocabulary. So in that set of words, we were maintaining each word uniquely. In this case, we will maintain set of characters that is also called vocabulary. But in this vocabulary, only the characters will be there, not only alphabetic characters, alphanumeric characters, special characters, whatever you want, you can store there. So in this case also, we have to maintain age. It is like this. You have to maintain this character. Here also you can use one hot vector. It's the same algorithms you can use. But the problem is here, if you see in this sentence, we have two words. So if I go by word, we have to if we write that either ASTM or UNIDEN or GRE or CNN whatever. So in that case, we will access only these two words. But here, if I want to access each word, I have to access these 5 characters. Okay, so and how to extract the meaning of the character? Because I know that from I know how to extract the meaning of the sentence. I know that. But how to extract the meaning of the character? Because there is no information about the character. Only H, only E, only L. So how will you extract the meaning of this character, this character, this character, this character? So if you want to extract this each character's meaning, so again you have to apply the whatever algorithm you were using, we were using to extract the meaning of the word, we were using to extract the feeling of the word or the to extract the relationship between words, same algorithm we will use it. So if you see for one word, if the vector size was like, suppose I had 10,000, I had a vocabulary size which has in that vocabulary I have 1 lakh words, 1 lakh unique words, and I have created what do heavy model where the dimension is 300. You can use 50 dimension, you can use 300 dimension, whatever. So the size of the matrix is 1 lakh into 300, the size of the matrix. So it will be the huge, right? It will be the huge component. It will be the size of the matrix is, if the size of the matrix is 1 lakh cross 300, it will be the more difficult to access this much data. To handle this much matrix, Okay, so what is this 300 dimension? The 300 dimension is, if I will say 300 dimension, I can apply 50. So at that time, the matrix will be 50. So what is this 50 dimensional? What is this 50 dimension? What is this 300 dimension? The same thing will be coming in the character also. But first we have to know that what is the meaning of 300 dimension. The 300 dimension is why when I'm saying that 300, I'm going to create the word to get model with 300 dimension. That means we are extracting 300 features from each word. That is why that is why the size is 1 lakh cross 300 dimension. The matrix size is 1 lakh cross 300 because each we are extracting 300 characters from each word. The same thing will be coming here also. So that is the more complex because if I will apply 300 dimensional word to the model in character, then how many characters are there in each word? 1, 2, 3, 4, 5. So in each word, suppose only for this word, it will be coming 5 cross 300. The matrix size for each word will be coming 5 cross 300. This will also come 5 cross 300. So for this whole sentence, how much it is coming? This is also 5 cross 300. This is also 5 cross 300. So it will be more complex to analyze this much data. But if you are able to access character by character, then that model will give you more accurate result than word by word basis, because in the character actually one word has created only by the character. So if I will know the inner meaning of the each character, then I can easily form the word. But it is but that is only the problem. So if I will apply this 1 lakh, if I will apply 50 dimensions, so if I am going to extract 50 features from each word. So after creating, this is called embedding matrix. Okay. So suppose hello, if I from this sentence, if I go word by word, so from hello, I am getting 1 cross 300 dimension matrix for this word. If I will go word by word, this is for 1 cross 300 and this word is for 1 cross 300. So this is separately, this is called embedding vector. These are the separately they are called embedding vector. When I am merging these, then I am creating 2 cross 300. This is called embedding matrix. Okay, so in embedding matrix, so what will be there in embedding matrix after creating the embedding? So think if you have extracted, if you will extract 300 features from each word, so it will be very much easy to find the similar words, right? Because I know you can extract 100 features, you can extract 1,000 features also, but actually this is the rule. How many features, if you increase the number of features, your embedded matrix will be created more accurately. But the problem is if you extract 1,000 features from each word, then it will be coming 1 lakh cross 1,000 matrix. So that will be very much difficult to handle by the architect, by the hardware side, from every side. So 300 dimensional is the actually standard for now. So in that, so this is called actually. So after getting this, when the word to make actually form, this is the graph. This is the graph. So suppose there is a multiple classes. This one class, this one class, this one class. I'm talking about the class. So they will create separate class. And suppose this is for human. This is for fruit. This is for animal. So this class will contain all the, not only the names, this class will contain all the information about animals. This class will contain all the information about human. This class will contain all the information about fruit. So now, so you have created this word-to-vec model. Now you want to apply co-reference resolution here. How it will work? So in this human, so based on your what to head model, your model will choose this for the human. So when it will come to the human, now you should know that this name belongs to male or female. So for that, inside this human, you have to apply again word embedding algorithm, which will separate those words which are related to male. So suppose this is related to male, this is related to female. So now, if you apply the co-reference, then it can easily go, suppose this is related to male, so it can easily get the information from this class, and it can easily get the information from this class. So this is the actual what do we. But the problem is when you will extract the feature, on which basis you will extract the feature. That's the another cause. So there is no specific rules that in this way you have to extract the features. So so when actually when what encoding fails, at that time they try to implement this. So this is because when how they extracted the features actually, suppose there are multiple words, suppose there are multiple words related to human, related to fruits, related to animal. So based on the data set, they scrap from the website or internet, whatever. So based on the data set, they can identify, suppose one word is there, suppose apple. Suppose apple. So in the case of apple, when you will go to extract 300 features, how will you extract? So you have a data set that I have a glass of apple juice, I have apple fruit or this. So from that you have to extract some parameters that based on these parameters I will extract. So you will have, suppose you have data sets about fruits, humans, anything, whatever. So suppose the parameters is juice. Parameters is juice, fruit, and man, suppose king. So when the word is coming apple, and again I'm saying that there is nothing 100%. So 100% negative, 100% positive is not possible. So when this is coming apple, so this is related to juice. Okay. So this is juice 0.7 and this is fruit 0. Suppose 0.8. So when apple is coming to man, I cannot write 0 here because 100% exact 0 is not possible. It will go tends to 0. So I can write 0.001, but I cannot write exact 0. King also same. I can write 001. So in that way, they have extracted the 300 features, or if you give 50, you have to extract the 50 features from each word, and you have to create the embedding. Embedding matrix. Based on the embedding matrix, they have created this graph. So if you want to plot this, I think TSNE one algorithm is there to plot the graph. You can easily know that how they are organizing here. So you will see there all the interrelated words, they are coming on the same place. Okay, go for lunch. It's lunch time. Features that you have to calculate. Yeah, that you have to calculate means, so you have the data sets, right? So from the data set, suppose if I say you have two class, forget about man, king, all this. You have two parameters, fruit and juice. So in your data set, you have to check that how many times this word has came with juice, how many times this word came with fruit, how many times this word came with man, how many times this word came with king. Based on that, you have to create that.
But there's an IDC algorithm. IDC algorithm there. is based on ID3 algorithm. Actually, in the ID3, we are taking entropy value and information value. After getting entropy value, we take the information value. What is the difference between information gain and ratio? ID3 is also similar to CRT, classification and regression. What is the difference between information gain and information ratio?
Information.
What is the difference between information gain and gain ratio?
Information gain is like information gain is the you have the data set, right? And information I'm going to information ratio first, then I'm going to information gain. So information ratio is suppose I just told that how many times this word apple is has arisen with this word in your data set. Okay, so that based on that you have to calculate the ratio. Okay, so suppose you have not seen, suppose in your data set this apple word has not come with man anytime it didn't come this word. So how will you give the value here? How will you calculate the information ratio? Then you have to calculate, like if you apply normal name base, if you apply normal name base there, then it will give you the probability value 0, because this is not existing with this. This is not actually in your data set. This is not with this word, but 0 is not acceptable actually. Actually, in the case of real world, 0 is not acceptable. Purely 0 or purely 1 is not acceptable. Some fraction value will be there. So how will you get that? There is one algorithm is there that is called add one Laplace transform. With this algorithm make this. Okay, so based on that, so in that case you will not get the value 0. You will get some fractional value. That is called the information ratio. Actually, how many times it came with this. It may come 0, but 0 is actually not acceptable in the real world system, because 100% is not possible. Okay, and information gain. Information gain is like here. Okay, but we say that apple is, for example, we are taking the apple, it comes under juice as well as fruit. So it will not never comes under man thing and all. So based on that ratio, we can do the no, see, it may come under man because the ratio is 0.001. It's not purely 0, right? So 0.001. So you have to search that where this apple is related to man or apple is related to king. So actually based on the ratio, after calculating the ratio, okay, so first you have to calculate the ratio. So after calculating the ratio, when you will see that apple has came with juice 70% times and with fruit suppose 80% time. Okay, so in the case of information gain, information gain, so it will be coming like you have to check that if this word, this information, this word may come under this or not anytime.
I know the information, I don't know about the information gain ratio. Information and gain based on the probability will be there. Information gain ratio based on number of times.
Anything else?
Why is it? You see, 156. That was the last time.
Stop recording now.
How?
Keep stop sharing.
Why are you sharing? You pass.
Pass. No,
See.
pass. Yeah. So sexy, right?
Okay. Now it's
Okay, so now we will go for hands-on live coding to build a model for conversational agent from scratch without using any library like Rasa or Google Dialogflow, nothing. So from scratch we will build one conversational agent using TensorFlow and Keras. So this is for live coding actually workshop hands-on. So for that we will take help from Google Colab, or if your laptop has GPU locally, so you can use your own laptop. And if anyone wants to use Google Colab, you can use Google Colab for the GPU. Yeah, actually TensorFlow will be there, and I need to access data sets. So for that I need the speed actually. If you use CPU for deep learning, then it will take huge time to train the model. That's why. So you can use Google Colab also with a have. And to train the model, it will take huge time. So so plan is like I will show how to write the code, and everybody will write, and I have already trained the model, so I can show the result here live. And based on that, because if I want to train the model now, so it will take little bit huge time. So because since it is a deep learning model, so it will take time. So I've already trained the model, and I will show how to write the code, and I'll explain code one by one. Yeah, I can see. No, I will explain one by yeah, I will explain. And if you don't want to train the model now, that is also okay. But I will just explain. because it is not possible to train here now writing after writing the program to train the model because it will take much time. So yeah, mine was actually this is a hands-on session, so like today with your okay. So I'm going to explain one by one. Is said I'm going to explain. And you guys open Google Colab for this. Okay, so if you want to share, you can share. So I will explain. No? How will you share? Mhm. Now, they need one or you can say that I will start. Okay, 21 okay, okay. Okay, okay, so it's not that much.
Yes, sir. remember. Not remember.
Okay, just download it and upload it. Okay.
Okay, if you want, I can download.
Okay, will download, but we need that file. Okay, I'm going to share this file. I said already is difficult.
Okay. Sure.
Just wait for them. Share this file. Okay.
So
Download this. Or else click on share here. What it will ask. Just click the shareable link. Just show this.
can you read?
Copy that. Just send it to someone. Wait 1 second.
Or I'm typing the code, no?
Okay, or else you will try type. You know, right? But if it is good, it's busy.
It is already training on one.
Okay, that's why it's showing busy. Okay, we have all the mail IDs. Yeah, that's why we send the confirmation. Just we have downloaded this file. Download this file. We have already download this file. Download the file. This motion download. What is this? Okay, just go to file. Look and try. From that you can able to download. Turn off this. Yes, I do. Yeah, download that. Okay, now wait. Okay.
Compress, okay.
Okay.
Now I'm sending to you.
No, wait. From here we will send to everyone.
How do you guys do? How do you became?
We will send to everyone. Those who came can able to use.
Download some conversation.
This one, right?
So we wanna have import. So we need to clear thought of this. It's showing initially, but it's not showing in this laptop. Wait, check. What is this? What is missing? What's missing? It's showing different in this laptop. Copied. I have copied from the reply no. In that case. Reply all. Okay. Or no, no. Go back. Go back in. Send as edit as new was the option there. It has new. Remove all this. After they have extracted, just try to import them. You just save the procedure. Okay, tell them to check the mail. Switching on, no? That's fine. Tell them to check the mail. Okay. We have sent the file, program, and dataset to your mail. All of your mail. Please check the mail and download that, and just upload that IPNB file in Colab or in any Jupyter. Just check your mail. We have shared the file in your mail. Just check your mail. So, yeah, just check your mail again. You're not receiving. You're not receiving. You also didn't receive. Okay. Air Not
Where is that file?
it's
Which
not
one?
you can copy the share link.
We have already done that. Anyhow, you will take a set, right?
Download this package. Let us
No, we are accessing separate file, separate data set.
where it is there.
So he has maintained separately.
How is being from local reference or it is applied?
No, he is using
You have any
the
local reference? Okay.
Okay, we have added in comment. Okay. From where you have downloaded the data set? Fine. Just see that we have uploaded in comment section.
In this link, you will get, we have uploaded in the link here in meetup.com.
Data set.
Data set.
It's in comment section. It's not that.
So I'll upload all the codes in GitHub also, right? We can upload that.
Just like
Yeah, not this. Okay, I have to download the data set. In downloads, one zip file is there, program is there, this inside everything is there, code and data set. So this is right.
எல்லாரும் இந்த லிங்க்குள்ள போக சொல்லுங்க. போட்டு அப்டேட் பண்ணியா? ஸ்லைட் எல்லாம் இருக்கு. They can able to download the zip file with the data set. Go to the link code. So everyone,
go to this GitHub website and you can clone the repository. So there you can able to find the data set as well as the Python notebook. The comment section put Meetup the comment section. Actually, what are the files? Only one data set. They upload this only repository, right? Ask. Yeah. Yeah, the repository is so inside this, go to the repository named chatbot building conversational chatbot. Check out it. So you got mail itself. Everyone ready? Does anyone have a problem? Another question. Answer download it. Everyone clone the repository. Just upload that file into Google Colab. Fine. Data should upload it. Can you explain what is the Google code? Explain. Okay, someone asked like combination of the velocity. No. Don't do that. They'll upload locally. They have file right now. They'll upload locally. Just say they want to access locally. Okay. They upload in Google Drive. They find one page in our Google Drive. Google everything is ready. How do you upload it? Or just just upload that file. You need to access the file.
I thought I just talked. Excellent, excellent.
Oh wow, nice.
Just like my daddy would. அடிபட்டுட்டு வந்துடும் ஆனா போதும் I thought it was not it's a whole world extra.
GL 553. Restriction GL 553. Yeah. 1.2
Did you guys activated GPU? You guys have activated GPU in Google Colab? Okay. Okay guys, after uploading the file in Colab, please activate it. Please you have to activate the GPU. And if you want to activate the GPU, first you have to go to runtime, then change the runtime type. Then there you have to select the GPU. Otherwise, otherwise it will take huge time to train the model if you will not use the GPU. So, okay, so done. Shall I start from cell by cell? Okay, so in the first cell I'm importing some dependencies. So because we will use some library functions. For those packages we have to import some modules or packages or dependencies. So that's why in first cell I'm just importing some dependencies. So this future first dependency, that first module is there from underscore underscore future. So it will handle all the absolute case. Absolute case means suppose if any truncation error will be coming, so it will handle those type of truncation error and fractional parts also. So it will remove that division is there. So what it will do, the division sometimes it will happen. Suppose if you do 5/2, so at the real time it should come 2.5. But for the programming simplicity, for the sake of simplicity, either we apply either floor function or ceiling function, right? So at the ceiling function, it will, if we apply 2.5 inside ceiling function. Ceiling function, because this is, so it, what it will do, the ceiling function it will convert it to 3. If I apply floor function, then it will convert to 2. So 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 those types of functions we apply for the sake of simplicity, because if we have to access 2.5, so it will be more difficult to access than 3. Because if you want to represent one integer in computer architecture, that is the more simpler to represent the fractional number. Because in the fractional number we have to take care of mantis part, exponential part. That's why every time we try to maintain this integer. But in ML or in DL, we should not ignore this type of fractional thing. So we have to keep all those things to get the more accurate result. That's why this dependency is there, and TensorFlow is also there, and Matplotlib I used to plot the graph. But now I will not plot any graph. So, and NumPy pandas, you guys know that what NumPy do. NumPy is used for matrix circulation, and pandas to read the various types of data sets and data science tools. And OS is there for to get the current directory path of any file. And Unicode data is like, see, so many Unicodes are there. Unicodes like, actually we there are, suppose if I write dash, there are 3 types of dashes are available. One is hyphen, one is m dash, one is n dash, but the structure is same. So it is very much, actually it is difficult to identify which is hyphen, which is m dash, which is n dash. If we want to identify which is hyphen, which is m dash, and which is n dash, we have to look very carefully to their size. So, but in some documents or in some data sets or in any text file, the author write in any way. Author can identify m dash in this way, m dash in this way, m dash in this way. So there are three types of dashes. So from OpenAI, it is not possible to identify which is hyphen, which is m dash, which is n dash, but their Unicode values are different. Hyphen has one type of Unicode value, M dash has one type of Unicode value, N dash has one type of Unicode value. Based on those values, actually computer system recognize which type of character is coming. So to handle those, I am using a Unicode data. Another is time, how much time it is taking to calculate that, and another is regular expression. So how many people knows about regular expression? So actually regular expression is, we can do many things using regular expression without applying ML algorithm. Suppose if I want to extract any name from a sentence, in that case also sometimes we don't need to apply ML algorithms or DL algorithms. We can easily extract entity or name using regular expression. So, but for that, you should know the proper pattern, that in which pattern the sentence may come, the name may come, the entity may come, so that without applying any ML algorithm, only by some pattern, only some regular expression rule, we can extract the name. So, regular expression is a very important thing in NLP. So, I am using the regular expression also to extract some patterns using some predefined patterns. Now I am importing the files. So please change the path where you are storing the file. Based on that, give the path. So here I kept the file in this path. That's why I was maintaining this. Okay. And this the convert Unicode ASCII. Convert Unicode ASCII. So some Unicode values may be there. So I am just converting all those Unicodes to machine understandable code. So now I'm pre-processing. So pre-processing is the most crucial step in NLP. And just remember, whatever pre-processing algorithm you will use to train the model, NFD is one type of Unicode will be there. So NFD and MN. So these are the unique code of some special characters. So I am just uh, converting those to machine understandable code. So after that, it is coming pre-processing. So just remember that whatever pre-processing algorithm you will use at the training time, you have to use the same pre-processing algorithm at the testing time. Because suppose you have used at the training time, if you use that type of pre-processing algorithm, where suppose you have used the pre-processing algorithm to access word by word basis, but at the testing time you are going to use the pre-processing algorithm, which algorithm will works character by character. So at that time the meaning will be changed. So you have to use the same pre-processing algorithm what you are using at the training time. You have to use the same. And this start and end, what is this? This in the sequence to sequence model, I know that one sentence may contain four words and one sentence may contain thousands words. So I don't know that which type of sentence is coming as an input and which type of sentence my model is producing. I don't know the length of the sentence. So and where the sentence is starting and where the sentence is ending, I don't know that also. So to identify that, actually, if I want to create that type of model which will understand where the sentence is starting and where the sentence is ending, to identify that I'm adding the start and end. So start will be, it will identify that from here the sentence is starting, and at the end I'm appending another end, so that the model can understand that here sentence is ending. So I am using these symbols, because if I would use only start and end, any sentence may contain the start and end word, right? So if the model will get start or end, then the if I didn't mention that at that time, the model will think that here the sentence is starting and here the sentence is ending. So to separate that, that is why I am using this symbol so that it will just it will give some extra meaning. Okay, and I'm in read.serve, the function of this module read.serve, what it will do? The read.serve, what it will do? This except these characters, whatever character will be there, it will be replaced by this space. So this symbol is identify this is not. If I remove this not, then it will replace all these characters by the space. So since I have given this not, that means algorithm will think that I don't want to replace this character. Except this character, if any character is existing, so it will replace that.
What is R?
R is for Unicode only to identify. Because since the text is fully unstructured, so many unicodes and so many encoded formats will be there, so we cannot understand which is there. So for to identify those things, I'm mentioning that. Now I'm just reading the data set and pre-processing. Okay, so if you look at the data set, you will see, just open the data set.
We handle smileys also.
Yeah, in this case, I'm not handling that. We have to handle. We have to handle smileys and we have to handle this type of dashes also, everything. If you want, you can add those code in pre-processing, no problem. So if you look at the data set, you will see this is the input question, this is the output question. Using that, I am training the model. So I created this data set in that way only. This, so it has separated by a tab space. Okay. That is not a factor. You can create your own data sets in any way, but in which way you will create your data set, you have to read the data set in that way. Since I separated by tab space, that's why after reading, when I'm reading the text file, I'm also getting the data set in that way. So after getting that, I have to separate which is the input value and which is the output value. So how will I separate that? I have already separated in the text file by tab. So here l.split, there is a split function in of a string. If you apply that l.split of \t, so it will apply, it will split those two words or those two sentences which are separated by the \t, one tab space. So it is separating and it is sending to preprocessing algorithm. After preprocessing, it is creating this list, then it is returning. Then language index. So this language index, that here we have to identify, we have to convert the non-numeric value to numeric value. So in this case, what I am doing? In this case, I am maintaining one set variable vocab. Why I am maintaining set variable? Why not list? Because in the case of list, the value, the word or the value may be repeated. But in the set, the value will exist only once. That is why I am maintaining here one set variable, this vocab. So how I am creating this vocab? So I am initializing this vocab using set variable. So after initializing this vocab, I am getting data from all the input. I have already that list. From that list, I am tokenizing each word and I am updating here. And after getting the vocab with a set of words, then I am going to create word to IDX. This dictionary is going to map word to uh, number, and this IDX2 word is going to map ID to the word. In this way, suppose in word to IDX, if I write in this way, hello equal to 1. So the IDX to y, so the IDX to word of 1 should contain hello. So IDX to word is the reverse of word to IDX. So why it is required? Because if I will convert each string to the numeric value, so at the testing time, when unknown value will be coming, so at that time, if the model will give you output as in numeric format. So after getting that format, but if I will show that numeric format to the user, then user cannot understand what the model is trying to say, which type of reply the model is giving. So I have to give the reply in string format. So to get the string format from that numeric, that is why I am maintaining this dictionary, IDX to word. So we will not use this IDX to word here, but at the testing time we will use this IDX to word. Okay. Now, another drawbacks of sequence to sequence model which has not solved, that is maximum length problem. The maximum length problem is suppose I have 3 sentences. The length of one sentence is 100. The length of second sentence is 80. The length of third sentence is 200. So how will you maintain? How will you maintain all these things? Because the embedding matrix or one-hot encoding matrix or whatever matrix you will give to train the model, the size of the matrix should be same. But your sequence size is different. One is 100, another is 80, another is 200. So the matrix size will not be the same. So we have to make it same. But how will you maintain that? So there are two types of procedures. One is if you have 100, 80, 200, you can maintain the highest length as a fixed size. If you maintain highest length as a fixed size, then you have to maintain here, you have to add here 100 again, because length was 100, you have to make it to 200. Here you have to give 120. So we can maintain that. But the problem is, suppose forget about 200. The size of the sentence is 2000. Then if you maintain here 2000, if you want to maintain this 2000, you have to add here another 1000. Sorry, add 1900. You have to add another. So it is not possible to maintain all this. Here you are saying 3 sentences, so each sentence is size 2000. So it's okay. 3 cross 2000. Instead of 3, if there are 3 lakhs, then it is not possible to access for any machine or any hardware. So another procedure is we can maintain the lowest length. So if I maintain the lowest length, so I have to, suppose it was 200 again. So if we maintain lowest length 80, then we have to remove 20 words here, and here we have to remove 120 words, right? I don't know if I will remove from here, if I will remove 20 words from this sequence, I don't know which type of words I am going to delete. I may delete some important words. In this case also, I may delete some important words if I want to maintain this 80. So in all the procedure, there are advantages and there are drawbacks. So if I will maintain this 200, so in this case, I don't need to remove any word. I don't need to remove any word, so that I will all the words will be there, so the model will get trained properly. But that is not possible for if I have 3 lakhs data set. So that is not possible to maintain the largest size, and I don't know that which type of what will be the largest size in my data set. So that's one problem, and this is also another problem. And if the testing time, so suppose, okay, for the simplicity I have chosen 200, but at the testing time, the user has given one sentence which has 500 words. You cannot test the model with 500 words because your model has already fixed up to 200. The since the model size is fixed up to 200, you cannot fit this as at the testing time. So again you have to remove here 300. So from the testing sentence, when you are removing 300 words, so you and me, no one has no idea that which type of words I am going to delete. So it may happen that those types of words we are going to delete which were containing very important meaning, very important feelings. So that is the main challenge, still main challenge in sequence modeling. But we have to maintain, we have to maintain any one of them. We can maintain one, we can maintain like this also. Actually, there is no fixed rule that you have to maintain this, you have to maintain this, you have to maintain this. You can maintain this also. So that 100 plus 400, 80 plus 420, 200 plus 300. So that we can do that. But that is the challenge. So again, if I will fix the length of the model with 500, so if it will come, then it will be create problem. Another problem will be there if I will fix the model with 500. Suppose I have a sentence which has the sentence which whose length is 2. Suppose suppose 3. I am good. The length is 3. But you have fixed your model length 500, so you have 100 data sets, so 99 data sets are okay, or 90 data sets are okay. Another 10 data sets, they have their length is 2 or 3 or 4 or 5, whatever. So if you if you have the data set length 3, so you have to add 497. What do you add? You cannot add another arbitrary word, because if you add another arbitrary word, then that sentence will contain another meaning. So we have to add some padding. That's called padding. So what is this pad? You can give any unimportant values. You can give zeros, you can give ones, you can give two, some unimportant value which you don't want to use. So okay, so 2, 3 plus 497. So you have added this pad 497 times. So suppose the value of the pad is 0. So you have added 0 497 times. So at the time of training the model, the problem will be coming. Suppose you have 100 data sets and you have two classes, apple and suppose fruit and human. Among the 100 data set, 99 data sets are containing the apple data, and one data set only containing the human data. So if you train the model in that way, your model cannot identify the human. So if you at the testing time, if you give any data about the human, the model cannot identify. So that same problem will be coming here. You are applying zero, you are adding 497 times. If you have the word I am good, then 0.0000497 times. At the time when you will train the model, you will be trained that these zeros will be overlap on these keywords. So your model cannot identify, your model cannot extract the original meaning of these three words. The model cannot understand, because the model will only know that I have to understand the zero, because zero is there huge times, more times than these three words 497. So that is a still problem, but we have to use. So here what I am doing, I am maintaining the maximum length. So but we have to solve these issues also. This is the fix. So to solve that issue, one architecture came, attention architecture, but that also didn't successfully solve the issue. Okay, so but real is something, but this is the very much difficult to solve that issue, because no one knows that which type of comment or which type of reviews is coming. Okay, so after calculating the maximum length, there is a function maximum length. So I am calculating the maximum length and I am extracting the maximum length from the data set. So now what I have to do, I have to load the data set and I have to create the pairs. Pairs means I have to create input set and output set. Okay, I had already the input set and output set, but that was in unstructured form, that was in string form. Now I am going to convert to number form. So first, input length, language index, question for answering pairs. So what it is doing, after creating the data set, I am going to go through question and answer. So question, first I am going to give question. So from that question, it will be converting all the string to number, and same thing will be answer also. Now input tensor, what is it doing in input tensor? So this has converted to string to number, but this will not replace those in the data set. So to replace those in the data set, this is working. This is for input and this is for target. Now I am calculating the maximum length of the input and the maximum length of the target. So here another problem is in conversational agent. If you have many to one sequence to sequence model, in that case you have to think only about the input length. But in conversational agent, you have to think both length, input length and output length, and you have to fix the both length. You have to fix the input length and you have to fix the output length. So here I am fixing the input and output length. Here I am just not fixing, here I am just checking that what will be the input length and what will be the output length. Now here I am fixing the size. What it does actually in pad sequence? Pad sequence, it does, see the, if you see the argument input tensor, max length and padding push. So there are two types of padding and see the padding is like I had three words, and so the sequence length is 3, and I have fixed the length of the sequence is 500. So I am adding here 497 zeros or ones, pad I am adding. So that is called padding, but you can pad in two ways. One is post padding, one is pre padding. Post padding is after these three words you will pad 497 times. Pre padding is first you will append these 497 zeros, after that you will append these three words. So that is it does pad sequence. Pad sequence is
first it will check that what is your which maximum length you have chosen, which length. So based on that, then the algorithm will check that the length of the sequence is less than this maximum length or not. If it is less than the maximum length, then it will add the pad. So I'm applying at post padding. Okay, so so then it will check that if it is less than this, then it will post pad zeros that time until it will reach here, or the sequence length is greater than 500, then that will remove. Okay, so after padding, then I am returning this values. Now, so I am loading the data set. So this train test split, I am applying here sklearn train test split, but we can do from scratch also. So how to do that? So do you know that why train test split is required and validation depth set is required? So to check that it is overfitting or underfitting like that. So here I am using this sklearn model, but instead of sklearn model, we can write from scratch also. Okay, because according to the actually what happens if you have the less number of data set, so you can split 80%, 10%, 10%. If you have huge number of data set like 10 lakhs, 50 lakhs, 1 crore, so at that time 98% is for training, it will go 1% for test and 1% for dev set. It will be enough to identify the model is going to overfit or underfit or it is okay. So I am just splitting here, and then now this is the batch size, number of batches, embedding dimension, units, and vocab input. I'm explaining everything. Okay, so first batch size. So what is this batch size? I am fixing the batch size is 64. So at a time it will access this much batches. So now this is the batch size. So we have to calculate the number of batches. The batch size is 64. Since one batch will contain 64 data, so we have to calculate the number of batches. So I have given a double slash because it will give you the integer result. That is why. So in Python, if I apply single slash, it will give you the fractional value. If it will come fractional, it will give you fractional. Otherwise, it will give you the integer value. That's right. So now embedding dimension is 256. This embedding dimension 256, and units is 1024. This is the neural network units. Number of units I am using 1024. And this is the vocab input size, and this is the target size. I am calculating that, and based on that, I'm creating that buffer size data set and batch. Actually, I have to create the batch. So based on the size, I am creating this. Now I am using here GRU. So what is this GRU? GRU is also one type of neural network, artificial neural network. So GRU, it is also it also solved that issue partially, long distance relationship. What is long distance relationship? Long distance relationship is, you have to remember, suppose some word is existing. So suppose that distance between two words is very big, but they have one relation. So that is called long distance relationship. So, but sequence to sequence model, it was suffering from that long distance relationship.
So to solve that, they introduced LSTM, ZRU, everything. So here I'm using ZRU. So this CUDNN ZRU, this is for if your GPU is activated at that time only it will work. Otherwise it will work normal GRU. So that is why I told that if GPU is not activated, then if it will execute, then it will take huge time to train the model, but it will use the GPU. Okay. Now encoder decoder. Okay, encoder decoder is an architecture in sequence to sequence model in deep learning. So, like attention architecture was developed to.
Here, what is units? Cost in here.
This is the number of layers that I initialized the just the before cell units equal to 1024. Yeah. Okay. So the encoder decoder architecture. Encoder decoder architecture is another architecture in sequence to sequence model in deep learning to solve the issue of conversational agent, like all the sequence to sequence problem. If I told you that in sequence to sequence there is a type many to many, if the input length is not equal to the output length, then there is a problem. How will you know that which type of output is coming? So, and I also don't know that the output length will be the equal to the input length or not. To solve that issue, that integrated encoder decoder architecture. Encoder decoder architecture works like that. Suppose the encoder decoder is, this is encoder, this is decoder. So the encoder decoder is, I am asking how are you? I'm just giving the high level. How are you? So it will return one value which will be fed to the decoder. This is encoder and this is decoder. So what will be the task then decoder? And the length of encoder will be the difference of the length of decoder. Because this encoder is the responsible to take the input. So it will work as per input length. Now it will come to the decoder which will be responsible to give you the output. Suppose I am good. I am very good. So here input length is 3, here input length is 4. So this is the encoder decoder architecture. So without this architecture, what will be the problem? If we will not use the encoder decoder architecture, then we have to maintain one single sequence length for input and for output, which will not be acceptable in sequence to sequence model. If I will maintain, suppose I have maintained 500, the maximum sequence length in input. Without this architecture, I had to maintain this 500 for output also. So since this is a sequence to sequence model, so I should not use the same length to the output also. It may come if input length equal to output length, that time it may come that 500 equal to 500. But not every time I can say that. So for that reason, here I have to maintain input length and I have to maintain output length. So many structures are there, and this encoder and decoder are the architecture. These are not the neural network. To build this architecture, we can take help from RNN, we can take help from LSTM, we can take help from ZRU, whatever. But these are not the neural network. This is the architecture through which architecture we can solve that sequence to sequence problem. So in this internal architecture, I can use LSTM, I can use RNN, I can use GRU. Here also I can use LSTM, I can use GRU, I can use RNN. So this. So first I am creating this encoder class. So in encoder class, see every time, so that batch size equal to, I have already defined the batch size, that how many batches will be coming, and encoder units, okay, and embedding, I'm creating the embedding vector, embedding matrix here, and this is the neural network. So this is one class, okay. So where we are creating the embedding matrix for this encoder model, and we are going to feed the data, because I'm going to give the batch also here. We are going to feed the data to the encoder decoder architecture model. Now I will create the decoder. That means after that I will create the model which will work with this full architecture, encoder and decoder. So that is the decoder. In decoder we will maintain that the output of the encoder. So if you will see in encoder, so this is written output and state, so that will be going to the decoder. So after creating the encoder and decoder architecture, so this architecture has already created. After that, we have to optimize the code. In the optimization, you can use any type of optimizer. You can
Initializing hidden state. What is
okay. Initialize hidden state. Actually, when I'm going to initialize the hidden state, I will give the batch size, because hidden state I can, it will not be visible, right? So in the hidden state, I will create the hidden state with batch size. The I am going to create one matrix actually, which will be the all the values will be the zero. The size of the matrix initially, the size of the matrix will be the batch size and decoder units.
it's weight, right?
Yeah, it's a weight.
Usually we do random initialization.
No, that is zeros. No, I am initializing with zeros. You can use random. You can use zeros. Because when I draw that RNN model, in RNN model, this, so it was giving one activation value to the next layer, right? So what was the activation value of the first layer? Because in the first, when the first, so it is giving one activation value to this. So what will be the activation value of this? Because they have to maintain the same architecture. We cannot maintain different architecture for different layers. So here you can initialize by zeros or random.
So not weight initialization.
Okay. Okay. Now the optimizer. So what is the function of what is optimized value? If I if I check if any polynomial equation, so the main goal of AI, the main goal of computing, the main goal of soft computing to find the optimized value in of either in linear equation or polynomial equation, anything. So in that also we used genetic algorithm, fuzzy computing to optimize the value. So here also I am using one optimizer, Adam optimizer from TensorFlow, and then loss function. And loss function is actually, it will give you that how much accurately, I mean how much loss is coming. So based on that loss, we can calculate the efficiency of the model. And I am not creating the model directly here. here I am storing the checkpoints. So what is the advantage of checkpoints? The advantage of checkpoints is, suppose the model is getting training. So at the training time, suppose I am entering here 600 epochs, 1000 epochs, whatever. Suppose when the model is getting trained, after few epochs, suddenly any error occurs, or my model or my system has stopped. So at that time, if I didn't store the checkpoints value, so again I have to train the model from the initial state. So that, suppose I have my epochs are 1000. I have 1 lakhs data set. So as usually, it will take huge time per epoch to train the model. Suppose after 100 epochs, my system got shut down, or anything bad, anything happened. So if I have to again train the model from the initial state, then that will be very difficult for me. So, but if I will store the checkpoints up to 99, so that because after 100 epochs, or just before after 100 epochs, my system got shut down or my program got crashed. So up to 100, all the training values will be stored in my local machine, so that I can I can I can restore all those 100 epochs value, and I can start train the model again from the 100 epochs, so that I don't need to train again from the initial state. So but the drawbacks is of checkpoint, it will take huge space. So because the space is it will take huge space. That is why not everybody use. If you have huge data set, that time we don't use tracking checkpoints, because it will take huge space, but it is good. Okay, now going to work with the model. So here the model is, I am maintaining here epochs 600. If anyone wants, the person can change the epochs. It may be 100, maybe 50, maybe 600, 6000, whatever. Okay, so because it is all about the try and error, right? So one time it is not possible to get the accurate value at a single time. So I have to train the model, then I have to test again, I have to train the model. If any error occurs, if anything bad happens, again I have to train the model. So I saw that 600 is okay, but if anything bad happen, anybody can change the epochs, no problem. Sorry. Okay. Hidden state actually, it is not visible. The main calculation is going to happen in hidden state. So some activation functions will be there. So initially, at the time of when it is a binary classification, at that time you can use sigmoid, you can use softmax. But the problem of the softmax is it is its time complexity is very high, because in the softmax equation there will be one summation will be there, very big summation, that is the length, that is depends on the length of the vocabulary. If the vocabulary size is 1 lakh, then that will be executed up to 1 lakh. So the time complexity will be increasing based on the uh, length of the vocabulary.
Based on the problem, we give the activation function.
Yeah.
How will we know which activation function we give? Suppose
That is actually there is no specific rule to choose the activation function, but you can choose between, suppose if you are using linear model, like if you are using if you want to solve one linear equation, 2x plus y, suppose 1. If you want to solve this linear equation, that time which you don't need to maintain the activation function also. Okay, but if you want to solve like x square plus 2x plus 4 equal to 0. For that you need activation function. Only you can choose that I need activation function or not. But there is no specific rule that you have to give this activation function, that is also try and error.
Continuous values, they were using different activation functions for constant values, we are using different activation.
No, that is different. That is for continuous value or for constant categorical value. That is coming either classification or the regression. Okay, I am talking about the classification. If you use regression, that is polynomial regression, linear regression, that is different. Anything else? So, are you guys executing the cells?
Yeah.
So it started for to train the model. Okay. Yeah, it will take time. That's why I actually for that reason I executed before, because I knew that it will take time. So if those execution will not complete, so that I can show you the result at least. That's why I trained before. We are going to solve the problem and we are using polynomial.
We don't know why for the
Only import numbers. कैसे जाएंगे दूसरे आए इधर है वीडियो में
क्लोज भी करना भाई business. साला तेरे यहाँ पे एक उसको हम किसी ने बोलता ही नहीं किया ऐसे कर सकते हैं ठीक है तब से इसको बना लेंगे हाँ नेक्स्ट में ऊपर आ गया
ಎಲ್ಲ ಪಡೆದಿಲ್ಲ ಸರಿ
error गया साला error पहला वही तो बोल रहा हुआ था पता कौन सा error ये वाला है मैं की तरह इसमें हो गई नहीं ना हमारा टेस्ट की अरे ये तो पाथ है ना पाथ तेरा आपको खुद का सेट करना पड़ेगा तेरे में ऐसा पाथ होगा ही नहीं उसका मेरा नहीं तो खुद का सेट करना पड़ेगा कहाँ पे सेट करना है डेस्कटॉप पे डेस्कटॉप कर ले डेस्कटॉप पे करूँगा तो पाथ का काम नहीं है So, we can actually go done.
Yeah, let me check once.
So try to save as a model.
It is giving different answer, man, from yesterday.
Okay, thanks. Thank you. Ask what I'm doing. Are you? Okay.
It's good, man.
State acceptance. But you said only KB. Explain.
So what you wanted, I can do some train the model with coordinate movie data set.
Bro, log this now. Function. Window L. Window L. Window L. Let me open.
நிறைய கேப்ஸ் இருக்கு.
You can ask continuously.
அதான் சொல்றேன்.
இங்க வந்து சும்மா அப்படியே போயிட்டு இருக்கு. We listen. If whether we could be able to follow or not, we just keep quiet. 100 சொல்ல இல்லை சொல்லுங்க எனக்கு புரியல அப்படின்னு சொல்லலாம். ஏன்னா நம்ம கிளாஸ் ஆமா அது எனக்கு ஃபீல் ஆகுது. இது வந்து 1 day வந்தாங்க அது நம்ம ஸ்டடி அந்த அளவு நம்ம குளத்தூரம் குருமன் எல்லாம் ஆரம்பிச்சாங்க. டாக்டர் ஏற்படலாம். சொல்லுமா. ஆமா ஒரு 5:30 கிளம்பு. யாருக்கு சரி 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 இதுல என்ன இருக்கு? இதெல்லாம் ஒண்ணும் நல்லதுதான். சரி 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 இதுக்கா பெருசா இன்னொரு விளையாடும் ரன் டைம் டிஸ்கனெக்ட் ரீகனெக்ட் போட்டு 600 என்னையா நம்ம என்ன பண்ணுவோம்னா அந்த ப்ராஜெக்ட் கான்ஃபரன்ஸ் பேசுவோம். You cannot physically go to you can தனியா அதான் 2 பேர் கனெக்ட் பண்ணிட்டு அதுக்கெல்லாம் எல்லாம் 4 வாரம் ஓடி
It will take, but no problem. I have already trained the model for me, so I can show you the result also. I knew that it will take time. For that reason, I trained the model before. How much it have? Yeah. JavaScript, I think TensorFlow has JavaScript version. TensorFlow.js. You can. I I don't know JavaScript. That is why I wrote in Python.
I don't know Python. I know JavaScript.
That is not an issue. You can apply JavaScript because TensorFlow has version TensorFlow.js. So you can.
We can use this Anaconda platform also to implement this, or we have to use this.
That I don't know. I didn't use JavaScript.
No. About this Python.
Yeah. You can use Anaconda.
Anaconda.
Yeah, Visual Studio you can use. You can use any type of editor, no problem. Actually, we use Anaconda for this because when we install the Anaconda, no, so that time so many packages are already installed automatically at the time of installing the Anaconda. That is why we use Anaconda. Otherwise, in the normal case, you have to install manually multiple times. When the error will come, you have to install.
Like in Visual Studio Code, we have to type.
And Python has its own IDE also.
Yeah.
Own IDE. That's called IDE. You can use that also, no problem. You can use Google Colab also if you need GPU.
It will be better if you use GPU.
I think they have TPU version also. TPU is for TensorFlow.
Yeah.
ஒரு சீரியல் அது வேணாம்னு சொல்ல அவங்க கிட்ட கேளு லேப்போட மாடல் நம்பரும் இது மட்டும் இது ஒரே நிமிஷம் இது டைப் அடிச்சிருக்கீங்க
Okay, guys. So training has done, or it's still training? Okay, so if you want, I knew that it will take time to train the model. So for that reason, I have already trained the model. So if you want, I can show the output now using that pre-trained model. Okay. So and you guys also can test after training the model in your system. Now I'm just testing here. Okay. So here I was not storing any model, right? I was just storing the checkpoints. So at the testing time, I have to restore the checkpoints what I have stored. So using this command, I restore the checkpoint using this command. So after restoring the checkpoint, so what it will restore actually, it will restore the latest checkpoint. So in that checkpoint, all the training information will be there. So okay, so check this evaluate function. So this function I will call at the time of testing with new query. So I told you that which type of preprocessing algorithm you will use to train the model. You have to use the same preprocessing algorithm at the testing time. So for that reason, after getting the query, I am calling this preprocessing algorithm so that the same preprocessing algorithm, the same preprocessing function will pre-process this sentence and it will remove all the whatever I wanted to remove and what I wanted to add, that Unicode and everything spaces. So it will remove all those and it will create the structured raw data. So after that, in this case also, I now what I am doing, in this case also, I have to convert the all the string value to the numeric value, because in this case also, because the model has already trained with the numeric value, so the model cannot identify the string value. So for that reason, here also first I have to convert the string value to the numeric value. So what happens at the testing time, suppose I have tested the model, like I have tested the model that I am staying in Chennai. Now, at the testing time, I have given the suppose I have trained the model with one sentence, but at the testing time, I have given another sentence that uh, I am staying in Bangalore. So I didn't train the model that I didn't train the model with this word Bangalore. I trained the model with the word I am staying in Chennai. So how the model will work, and so how what we'll do here. So here, after getting the test value from the user, we have to check that which words are available in that vocabulary list. So which words will be available in that vocabulary list, we will replace all those words by the numeric value from that word to IDX dictionary. But which word is not existing in that vocabulary list, what will happen with that? There, another padding will be worked there, that is called unknown, to identify that this word is unknown to the model. For the unknown, we have to maintain one another value in word to head dictionary. So in word to head dictionary, we were maintaining the numeric value of start, the numeric value of a, the numeric value of pad, then and we have another the numeric value of unknown, so that we have to identify that this word, if this word is not existing in the vocab list, so we have to tag that as an unknown, so that the model can identify this is the unknown. For that, the model, if I take the model like in this way, I'm in Bangalore and I have trained the model, I'm in Chennai. So now, because already I have trained the model, I am in Chennai. So I am in. These three words are already existing in the vocabulary. So I will replace all those words with the ID or with the numeric value which are there in word to IDX dictionary. And then now testing time I am giving that I am staying in Bangalore. So instead of Bangalore, I will give unknown unk. So here also I will use the pad sequence. Pad sequence in the sense, so in sequence I told that if input length will not be equal to the output length, and we have to maintain the length for input and output for both. So suppose for the output length, suppose I was maintaining 500, the maximum sequence length, and at the testing time I'll be giving like I'm staying in Bangalore. So the length is actually 5. So instead of 5, but I was maintaining this 500 as the maximum length. So again I have to do one pad sequence model. I have to execute that pad sequence so that again this padding will be happen. Because the model has fixed with the size 500. So after that, what will I do? Now I have to convert to the tensor. That this is the part of pre-processing that I had already done in the training time. Okay, so attention plot is there, but I didn't plot. I commented that plot. Here I was maintaining little bit attention architecture also to give the more. What is actually in attention architecture, what happens? You have to, when I am typing like I am staying in Chennai, when you are reading that text, it is not possible for you to assign to give same attention to all the sentence, sorry, to all the words. It is not possible for a person to assign sorry to give the attention same attention to the all words. So it may be differ. That is the actually that is the main work in attention architecture. So if we will not maintain the maximum length, if we don't want to maintain the maximum length, in that case we have to give more attention on those words which are more useful to extract, to identify that sentence uniquely, whose features. So this is the main task in preprocessing, that we have to identify one sentence, we have to identify one speech or document uniquely. So in this translate, this is the function. This will take the sentence and encoder, this encoder value and decoder value. in this case also will be there, and input language, target, everything. So in the case of target, it will give you the after getting the value from this, it will give you the output. So now I am restoring the checkpoints, then I am giving. So here I didn't maintain any separate test file, because I thought that otherwise I had to store again the value of encoder, the value of decoder, and the value of checkpoints. The problem to save the checkpoints is it is the size of the checkpoint is very high actually. So it almost after training the model, if you check the size of the checkpoint folder, I think it will exceed 15 GB almost. Okay, because according to my code, after 2 or 3 epochs, I was storing as a in a checkpoint folder. It is not mandatory that you have to store after 2 or 3 epochs, and it is also not mandatory to maintain the checkpoints. But I told the advantage of checkpoint, that why I was using the checkpoint. So that is why I maintained that, and since I had 600 epochs and I was maintaining, I was storing the checkpoint after two epochs. Uh, that is why the number of epochs, sorry, the number of checkpoints was very high. That is why the size is also very high. So now at the testing time, I have restored the latest checkpoint from the checkpoint directory. So after restoring that, now I will give you, I'm going to give a new sentence, and I'm calling this translate function directly. So for that reason, I am not maintaining any test file or test Python file. I'm just testing from this file only, because model has already ready, and your model is also going to be ready. I think it is almost and okay, and I'm not saying that this model will work every time very good, because we cannot say that when the AI model will work properly, when the AI model will not work properly. This will be very much difficult to say every time. So sometimes it will be working, and sometimes it will not be working. For everybody this happens. So if this will not give every time properly data, then again you have to change some hyperparameters. You have to change the epochs, and you have to change the hyperparameters. You have to change the data set. You may increase the data set and train the model again. So okay, so I'm just testing that what are you doing. So the model is giving, I'm filling out my college application. So if I test with another also. So in this way it is working, but I can't say that it will work with any type of query. So sometimes it will not be working. So this was my query, that can we meet today? So the reply is no, thank you. So in this way, we have to create the training model, and we have to test the model. So here I used GRU. You guys can use LSTM or whatever you want. You can use hidden Markov model also, because hidden Markov model is also very good algorithm for sequence to sequence model, since Still it works very good in speech recognition hidden Markov model, because actually hidden Markov model also works like graph structure, and it also calculates the probability that these words, how uh, what will be the probability to come the second word, what will be the probability that this word will be coming after this word. So in that case also hidden Markov model works very well, because it also works in graph structure. So you guys can use uh, LSTM RNN. In this case I used bidirectional, because if suppose if the query is very long, so I had to go through from both side, from top start to end, and from end to start. So because I had to know the meaning of the future words also, and so many drawbacks are also there in deep learning, this in this sequence model. I have explained those things also, what will be the drawback. So scientists are trying to solving those issues. So now whatever we have trained the model, and in this case and if you want you can change the pre-processing algorithm also, because the pre-processing algorithm is the most crucial part in NLP or ML, in any ML type, in any ML program. So if you change the pre-processing algorithm, it may give the good results, and if you change the hyperparameters, then also it may give the good results. And I tasted that it was not that much overfitting, and checked that it will try not to overfit the model and underfit also, because overfitting is also not the good thing and underfitting is also not the good thing. So we have to test that. In this case, I splitted the data set into train and test. But now we have to split in three: train, test, and dev set, to get the proper to get the accurate result. Because actually what happens, human accuracy sometimes, and when the deep learning not came, when the only statistical algorithm came, at that time the machine accuracy was lesser than human accuracy. But after the deep learning few years ago, in image recognition, it happened that machine accuracy is better than human accuracy. So what happens actually, but not every time, because the extreme error term is there, that is called Bayes error. Bayes error. The human also cannot reach that error. This error is the lowest possible error. So human error is also greater than this Bayes error. But for the sake of simplicity, we assume that human error is equal to the Bayes error, but human error is also greater than the Bayes error. So human also cannot identify all the AI model properly. So we have to change some data set. We have to check that this is the Bayes error, this is the human error, this is my model error, this is my expected result. So how much it's differing and how much percentage it's differing. So based on that, we have to change the architecture. So if it overfits the model, that means you are using more epochs and your architecture is very strong, but your data set is very less. So in that case, you have to increase the size of data set. So that will solve the overfit problem, but that will not solve every time. And in underfit also, underfit is also not good. So solve the underfit and overfit problem. Okay, so this is one type of only one conversational agent hands-on for to build the conversational model. So many sequence to sequence will be there: machine translation, speech recognition. So and speech recognition, machine translation, and document summarization also. So and I today morning I told that I'll talk about the unsupervised document clustering. How to do that? Unsupervised document, not document clustering. When the term is coming clustering, that means it is unsupervised, right? So first we will think what is document classification. Document classification is like if you have a folder structure. So one new document came and based on the folder structure, based on the folder names, based on the content of the document, you have to classify the document. So how will you do that? In classification, so it is since it is a coming classification, so you have used a set of data and you have files under each folder. So what will you do that? When you have supervised data set, so which documents, it may be PDF document, it may be text document, it may be CSV, any file, any type of document, first you have to extract the keywords. After extracting the keywords from the existing document, you have to store inside any file or anything. So when the new document will be coming, same keyword extraction algorithm you have to apply to extract the keywords from the upcoming document. So after getting the documents, suppose this list is containing the keywords of previously stored dataset, and this list is containing the keywords of upcoming dataset which is coming, the new key. So nk1, nk2. So now you have a folder structure and you have the set of data, set of documents. From that you have got the keywords and this is the keywords of upcoming document. Now how will you classify them? So suppose if you will apply deep learning or machine learning, you can apply, but the problem will be there if you have huge documents, then each document suppose contain 50 pages, 100 pages, so it will be very much difficult to identify the document first. So for that, we first what we have to do here, for that reason we extracted the keywords. So after that, we will calculate the similarity between the keywords. We will calculate the similarity between the keywords. There are so many algorithms available to calculate the similarity between keywords or to calculate the similarity between words. So after calculating the similarity between words, you have to take that value whose similarity value is the more. So how will you calculate? There are so many, like if you use cosine similarity, you can use Eric distance, Euclidean distance, whatever you can use. So after using those, after getting the similarities, you can easily classify. So you can easily store that new document to the specified folder. But if it is document clustering means this is fully unsupervised. You don't have any data set. You don't have any folder structure also, and you don't have any files also. I have given you 10 files. You have to classify the 10 files without any folder structure. How will you do that? Without any folder structure, you have to cluster that 10 files. This is coming under unsupervised. That is why document cluster. So, since you don't have any folder structure and you don't have any documents, then you have only 10 documents that you have to classify, that you have to cluster, you have to store in your system, local system, so that when the 11th document will come, you can store easily. So you have 10 documents, D1, D2, D10. First, you have to extract the keywords from D1. You have to extract the document, you have to extract the keywords from K2 like that, K10. So K1 is not one single keywords. This is the list of keywords. This is the list of keywords. This is the list of keywords. Now, now you have extracted the keywords and you don't have any folder structure. Now you have to create the folder structure. How you create that folder structure? You have list of keywords. Now you have to compare between these two list of keywords, and you have to check you have to calculate the similarity value. This, this, like that. So in this way, this. So after getting the similarity values, you will get to know that these documents will be coming under these tags. In that case, tags will be the folder name. So, but you cannot choose any tags. You cannot choose any tags randomly. Suppose one keyword extractor. Suppose you have applied one algorithm which will extract the keywords. There is sometimes it has extracted. Suppose off as a keyword. So the folder name should not be off, right? So what you have to do after extracting the keywords and after calculating the similarity, what you have to do now, you have to check that which names are more perfect to give as a, I mean, which names will identify one or more documents uniquely. I mean, very genuinely. Suppose you have documents about business, about sports, about education, like that. Okay, so these documents should be coming under that folder only the whose name is any business related, whose name is the business related. This is for suppose sports. So these documents should be coming under any name, any folder name which is related to the sports. So if this is education, so this should come under any with that folder name which is related to the education. So how will you do that? This is not one type of topping modeling. This is not the proper topping modeling also. So after getting the tags, you have to calculate in your environment in another topics that which is the which will be the more accurate name. So suppose from this keyword and this keyword list and this keyword list, after calculating the similarity, we have got suppose football, forms, like that. So you have to assign this under this. Now you have, after calculating, suppose you have give this tag set football and forms. But you cannot give the folder name football and force, right? Force. So you have to create one hierarchy there. That now you have to check which is the hypernym of which word. Which word is the hypernym of which word. So I'm not saying that force is the hypernym of football. Another words may be there. So that time you have to check that if force is the hypernym of football, so force will be the parent folder name. One subfolder will be there whose name will be the football. Inside that football, that document will be coming. That document should not come under forms directly because football is the subfolder of forms, and that you have to calculate that you only that time you can do that if you can extract the hypernym relation. So without extracting that hypernym relation, you cannot understand that which is the parent, which word is the parent of which word. So if forms is the hypernym, so if another words is there, suppose cricket. So and suppose Forbes is the hypernym of cricket also.
So Forbes is hypernym of cricket and football. So they are the siblings. So this term is called co-hyponym. So then football will be the hyponym of Forbes. Forbes will be the hyponym of football. Since Forbes has two hyponyms, these will form the co-hyponym. So at that time, these document D1 and D2 will be split into two folders, cricket and football, which will be the subfolders of Forbes. So in that way, we have to create the folder names in document clustering since we don't have any folder structure, any document previously. So after getting, if you have one document, then what will you do? If you have one document, here you have 10 documents so that you are calculating the similarity and this you are creating the folder structure. If you have one document, then after extracting the keywords from that document, then so if I have one document keyword list, so I will calculate this directly. So at that time we don't need to calculate the similarity between this keyword list, this keyword list. We will calculate the similarity between this keyword and this keyword. So which will be the more similar? Which will be the more similar means suppose cricket is more similar to football and folk. So we will maintain cricket instead of these two. In that way we will reduce the number of folders. Otherwise it will create one by if you will not maintain the similarity values or if you will not maintain the highest similarity value that I will take. Otherwise, suppose if one document has 50 keywords, so it will create 50 folders to store only a single document that is not acceptable in folder hierarchy. So for that, again you have to calculate, you have to extract the similarity, that hypernym. So which folder, which word is coming under which word, based on that you have to create the folder structure to store the document. Otherwise, if you will not that, then again you have to maintain all those folders to store one single document only. That is the document clustering problem. And that was the document classification. If you had previously folder structure and this, that was the document classification. But this document clustering has so many drawbacks since you don't have any data set, any folder structure. So it will be very much difficult to choose the folder name. So if you are able to choose the perfect folder name, then it is okay. But some maximum time it will be very much difficult to choose the perfect folder. You can create the folder, that is not an issue. You can create the folder from the tag list, from the keyword list, but to choose the perfect folder name, that will be the more difficult task since you are purely since this is the fully unsupervised, not semi-supervised also. Actually topic modeling is just one type of semi-supervised document classification also, but document clustering is the fully in unsupervised, not in semi-supervised. Okay. Okay, so today, and anybody has any question? If anybody has any question, then please can you ask? From Google Colab. Okay. Actually, if you close the Google, it will not be stored.
Go there, he's calling.
Okay, okay, sorry.
Yeah. So hello everyone. So how was the session? Has anyone? I mean, how much have we gained knowledge? A lot. Everyone. So okay, kindly share your feedbacks. I mean the link. சரி ஓகே சரி நீ தான் கொடுக்க போற நம்மளுக்கு சர்டிஃபிகேட் completed. So for you, I mean, what I'm trying to say is like, so for a small gratitude, I like to present a small momentum to the presenter Deva Vidya. So the coding will give the momentum. So how was your experience by learning this chatbot building? Can anyone say what you have gained today? Anyone?
So today we learned that we totally new to we, so we learned a lot of things from the basic to how we are citing the algorithms, how the algorithms work, and each and every for the example we are executing the hands-on exercise. So we explained that. So initially we had a theory section and then we hands-on. so we can map it easily. Why we are using, why these lines are used. So likewise, totally nice, very nice.
Thank you for feedback. So anyone can able to say, I mean, anyone is interested to say what you have gained from this session? You want to say something?
Actually, this is my first time attending something like this.
Okay.
So previously, I have not attended anything like this. So first event was very good, and then continued with the Python programs. It was very good as well. So I guess this was a pretty nice experience for me. I hope that in future times we can also come back and learn more about this one. So thank you, sir, for teaching us so nicely, and I enjoyed it.
Okay. Okay, thanks for feedback.
No, it's actually pretty early. I thought you guys, with the way that you were all refusing to go for lunch, I was going to go to 8 or 9.
I had a plan.
You had a plan? But then who told you to stop it?
Completed yearly.
Yeah, Prasanna? Okay. How many of you would like to actually have a series of this session, a follow-up session on this?
Yeah.
That's all hands up. Thanks, and I hope all you found your Sundays very useful. So I did a special thank here for Kesavan, who kind of came in. I know these guys work somewhere really really far from here. He said it's a 2 hour journey from where he works in here. We had to take off, come here, meet, look at the office, make the whole planning done. Brought in Deb to kind of do the whole session, kind of arrange everything. So thanks a lot from my side and everybody from Arithmetic side to School of AI team and to Deb. And I have a small gift for the man who spoke the whole day. I know he was talking the whole time. So here. So anybody would like to actually run the session on this, you can always reach out to Prasanna or me. I mean, I'm sure everybody can do one session. If you ask me, I can tell you how to talk. That's my job. So maybe, or any of you have some, expertise in that you guys come with, feel free to step up and share your knowledge. I think that's whole community sessions are all about. Any questions? Okay, thanks a lot.
One more. So for the past 1.5 months, we are suffering in sense like we are planning for meetups, but we could not get able to proper venue. So at the last moment, we have approached Altimetric team and I spoke with Abhimanyu ma'am. So they have given us an opportunity to conduct a meetup like this. So for them, a small momentum.
Thank you. People are going to ask me all the way on a Sunday, what are we going to do?
They have gained more knowledge.
Okay, good. Thank you. Thanks a lot.
Okay. At last, we'll have a group photo now.
So just want to know, is everybody registered when you came in, right? And also everybody given your feedback because it really helps to know where we are and what are the areas that we can actually work on. So if you have not done it, we request you to kind of take a few minutes. We've done it very simple, just few time for us to do that time.